Ladies and gentlemen, welcome. Good afternoon and welcome to the Vanguard Initiative Regional Conference. My name is Anna Butrym and I'm so happy to welcome both our audience here in the studio and also all those who are watching us online via our streaming. We are so happy to have you here with us virtually. We are starting this very important event right now, and we are welcoming all of you from the Krakow Technology Park headquarters. The event is a part of a broader series of events, Małopolska Festival of Innovation, that takes place between 20th and 26th of June, but the debate on the innovation starts today, and we are going to explore the secrets of hydrogen and hydrogen-related technologies as the fuel of growth. Firstly, before we'll start our theoretical part, I would like to give you some background on our today's meeting. And the first important information is the thank you. Thank you to all the partners without whom it would be possible to host such an event. And the Vanguard Initiative Regional Conference is organized by Marshal Office of the Małopolska Region, Department of Ownership, Supervision and Economy, and the strategic partner of the conference is Polish Cluster of Composite Technologies. Ladies and gentlemen, for many reasons, this is a very special event. Most of all, this is the first regional conference to be held in 2022, and it's so good to have you all here in Krakow and to start the series of various events that will be organized throughout Europe in various cities. They will be focusing on various themes and challenges, but they all have one thing in common, and this is the cooperation in innovation as the theme of those events. Please let me remind you that Małopolska is consistently growing stronger and stronger as one of the foremost innovators in Poland, as the region that is standing out in its effort to show you how we can be innovative, especially in terms of the ecosystem. This wouldn't be possible without the wide cooperative work, and every day this work is being shown at the local level, where the representatives of business, science and administration work together on new projects and ideas and solutions. But the whole spirit of cooperation goes beyond the region, beyond the Małopolska region. And for many years, the regional institutions have been active partners in the international and interregional initiatives. And they were learning from the more advanced regions in Europe. And here we are today with our advanced knowledge about the topics that we're gonna present to you. We really appreciate those activities and the networking within the Vanguard Initiative partnership, and we are very honored that it's been a year since it's been announced, and now we are here in Krakow and we are celebrating here in this very center of Małopolska region this long partnership. And I have to remind you that Małopolska was one of its founding members to the Vanguard Initiative, so it's especially dear to us to be the host of this conference. Accelerate the Process, Hydrogen as the New Fuel of Growth conference is a proof that Małopolska really knows what should be done within those new trends in technology, what is in trends and what should be discussed. But we all know that the problem of the energy in Europe is something far wider. We are struggling to think about the future of the Europe in terms of maintaining the current standards of living in Europe, but we are also facing new challenges apart from those that we knew up to this moment, and those challenges will be connected with the dramatic situation in Ukraine, when we one day discovered that anything that we thought was a long-term process that is somewhere far in the horizon was proven to be the problem of today, to be solved here and now. The problem of energy is no longer a political debate only. This is also has also a strong social element, and this is especially visible when we take into consideration the green energy dilemma. So the energy that is produced and processed in the eco-friendly way and is bringing some safety to the world that we are living in. But I'm sure that together with the guests that we are having here today and virtually with us and also here in this very room, we will be able to come to some solutions and conclusions and some good news for the future. And ladies and gentlemen, you can also be a part of our initiative of our today's discussion, because we will have a Q&A session at the end of the day. The ones that are joining us through the live chat live streaming can always post the questions on the chat, and we'll be gathering those questions and addressing them at the end of the day during the Q&A part, the Q&A debate, but we'll be also then collecting the questions from the audience. So please keep your questions till that moment. We won't be accepting questions during the presentations, but we'll be happy to address them at the end of the day. And having said that, I would like to invite you to the first presentation of today, which of course is the official opening. Józef Gawron, Deputy Marshal of the Małopolska Region, would like to welcome you all.
Thank you. Dear ladies and gentlemen, on behalf of the Małopolska Region, I would like to cordially welcome all our guests at the Vanguard Initiative Regional Conference, which is held as part of the Małopolska Innovation Festival. I am very satisfied that Małopolska Region remains an active partner in interregional dialogue on innovation and a place where theory meets practice in this dimension. I also hope that there will be a lot of opportunities to establish valuable contacts, develop interesting ideas for joint ventures that fit the subject of the conference, or to compare past experiences in the field of hydrogen technologies. I wish you all an interesting and inspiring discussion. Thank you.
Been heard in the room, and we are now sure that we will hear all the next presentations as they should be heard. And having that being presented to us, we can connect with our first live presenter. Farah Brahmi, Vanguard Initiative Network Manager, is ready to be with us online to present the subject of the place-based European network leading by example to boost regional innovation ecosystems. Good afternoon.
Thank you very much for the introduction, the invitation to this regional conference. This is very much appreciated by the Vanguard Initiative, the full membership, to see that Małopolska is taking a leading role organizing this conference and also on various topics such as hydrogen. I will try to be very brief. I just would like to set the scene for the discussions to start. And so in order to do so, I just would like to introduce you to the Vanguard Initiative briefly, for those who are not familiar with the Association of Regions. So the Vanguard is gathering 39 of the most advanced industrial regions of Europe. And so we work according to 7 pilot projects. So you have the topics of the pilot projects which are listed here. So we work on nano, bioeconomy, efficient sustainable manufacturing, 3DP, advanced manufacturing related to energy applications, smart health, and artificial intelligence. This work is delivered through 5 task groups. And so the idea is really for you to understand that the secretariat of the Vanguard Initiative is only me and my colleague Eleonora Nadine. And this means that our role is mainly to coordinate the activities which are rolled out by the members themselves. So the task groups are really where the member regions are collaborating to make the work of the Vanguard a reality. And they coordinate in order to make sure that the pilot projects can deliver from a place-based approach. So here, what do we mean by the place-based approach? We mean that the work of the Vanguard Initiative is really based on what's happening in the regional innovation ecosystems of its members. And the main aim of the Vanguard is really to support the development of the regional innovation ecosystems of the members through collaboration. So we have 3 goals in order to achieve this. We first want to support SMEs and intermediary organizations to increase the competitiveness of the companies, to support innovation, to help clusters, competitiveness centers in taking part in the activities of the pilots. We also have another goal of interregional collaboration, where we work very much on co-funding and co-investment, where we try to look at all the possibilities regarding synergies between the regional, national, and European funding instruments. And finally, we work together towards policy influencing. So these are the 3 main, let's say, projects of the Vanguard Initiatives, which are all encompassed in order to boost innovation ecosystem development across Europe. The most important aspect of our work is really the pilot. So the most important aspect is really the fact that we want to be place-based and we want to support actors on the ground to support the development of new value chains and thereby innovation ecosystems across Europe. So within the pilots, we follow this methodology: learn, connect, demonstrate, commercialize, on the basis of the smart specialization strategies of the members. And thanks to the political commitment of all the member regions, the regions get to learn about themselves on a specific topic. So here we could take the example of hydrogen. Should there be a pilot on hydrogen, first there would be a learn phase where all the interested regions would learn about each other to develop scoping papers, see what could be achieved. And then we would go into the connect phase in order to be able to get to the demonstration phase, so sort of like kickstarting demo case activities. Once we kickstart demo case activities, it has to be at TRL 5 at least. And then the demonstration activities would be serving the TRL 6, 7, and 8. The aim is to get to the point of commercialization in a specific demo case in a pilot. So that's for the methodology within a pilot. Just to let you know, we have a new pilot call, which has been launched recently, and we have a General Assembly vote, which is open. This means that the members of the Vanguard are currently voting on what will be the next pilot. So we have received 2 applications. There is 1 application on hydrogen. We have also received a smart marine ecosystem application. The board of the Vanguard Initiative has given its recommendation to the General Assembly to select hydrogen. This said, the membership does not necessarily need to listen to the board recommendations. I looked with my colleague at where we are with the voting procedure at the moment, because it's an online voting procedure, and hydrogen is quite well placed so far. So we can be quite hopeful. At the moment, there is no vote for smart marine ecosystem. All the votes are going for hydrogen, but they haven't reached majority yet. So this is not like a certain, like a sure win. We are still waiting the closure of the voting on June 16th, but hydrogen is well placed. So the discussions today could be very fruitful in that direction. Very quickly, I would like to inform you, if you're not aware, that we have an SME call. So the SME call was launched Friday. This is a quick slide to let you know what the SME call is about. That was under the leadership and initiative of Steinbei's Europazentrum in Baden-Württemberg. So this is a slide from Petra Püschner, who proposed that idea to the Vanguard Initiative members. The Vanguard Initiative members approved it. And so we have a call for SMEs. They can get up to 11K to either access a service or a technology allowing them to participate in the activities of the pilots. So since it was launched on Friday, I didn't have the time to prepare a slide, but if you're interested on that call, you can find the information on the Vanguard Initiative website, or you can email sme@s3vanguardinitiative.eu, or you can contact me directly and I will give you the details. This is the cross-cutting call. So this is for the board, the Vanguard members to remember that we have a cross-cutting call every year. So we have the cross-cutting call open since 1st June. So it's above 20K available for any type of activity which would be supporting the Vanguard Initiative's goals. So it can be in the framework of a pilot, but it can be in any other framework. And here also to let you know, and that we have just hired an expert, interregional funding expert. And this is one of the reasons why I will not be able to continue to participate in the discussions today. I'm sorry, I'm basically double booked. The Vanguard Initiative is kicking off this expert interregional funding activity today at the same time at this conference. So during this exercise, which should be lasting 18 months, we intend to look at potential solutions to fund collaboration amongst Vanguard regions, amongst European regions. So it's really looking at potential options for co-funding and co-investment in order to facilitate the work that already regions are doing at the moment. And we would be also applying for the call European Innovation Ecosystems, the Connect 0201 call. So that's for you to be aware. That definitely would have some positive repercussions on the activities of the members within the Vanguard, but outside the Vanguard as well. So that's it. I hope I haven't been too long. I don't want to take all the time from your discussions, more focused on hydrogen.
This introduction. Thank you very much for being with us. Ladies and gentlemen, let's move to the presentation of Luca Polizzi from the Directorate General for Research and Innovation at the European Commission, who will present the role of the region in the clean hydrogen transition from a local to a global perspective. Do we have the speaker with us?
Hello. Good morning, everyone. Thank you very much for the invitation. Thank you for the Vanguard regions for the opportunity to present the European strategy and what Europe is currently doing to support the hydrogen transition. So just a couple of words of introduction. So we know that we have a specific goal to achieve. So we need to keep our global warming temperature below 1.5. We have an international cooperation agreement, that is the Paris Agreement, that is giving directions and bringing consensus towards that goal. And we know that in order to do that, we need to substantially decarbonize our society, the way we live, the way we work, the way we travel. And in Europe, we set with the European Green Deal a specific cooperation framework with a number of activities and actions in order to achieve climate neutrality in Europe by 2050. And there's a number of initiatives, and across them, hydrogen can play a key role in supporting the decarbonization of our society. So that's why so much focus has been given to hydrogen recently. We know hydrogen has an enormous potential as a fuel, as a carrier, as an energy stock. So that's why it's so interesting to support the decarbonization of certain difficult to abate sectors like transport or heavy industries. But in order to do that, we need to make sure that the hydrogen we produce is green hydrogen. At the end of the day, hydrogen is a molecule. So when it's burned, it releases water. So there's no emissions. But how the hydrogen is produced is going to be critical for the European approach to climate neutrality. So we want to be sure that the hydrogen is produced through renewables in order to have green hydrogen. So we have, as said, a wide European strategy to support that in different pillars. So pillar number one, as you can see on the left-hand side of this slide, we have a target by 2024. So produce install at least 6 gigawatt of renewable hydrogen electrolyzers in Europe to produce 1 million ton by 2024. Then the second pillar of this strategy is bringing up the threshold, and we want to install at least 40 gigawatt of renewable hydrogen electrolyzers by 2030 and produce 10 million ton. By 2030, all these should be scaled up and deployed. Well, in order to do this, we need an accelerator, and the accelerator approach is provided by Repower EU. So we know that Repower EU is the mechanism that the European Commission is putting in place to support Europe independence from Russian gas, but accelerate at the same time the transition towards renewable energies. And Repower EU has a specific section dedicated to hydrogen, where it considers hydrogen as an accelerator. So Repower EU, the demand for renewable hydrogen, and we should produce at least 10 million tons of green hydrogen in Europe by 2030 and import another 10 million tons of green hydrogen from non-European countries. And as part of this, we have we have a number of initiatives that the Commission is taking forward. One of those is doubling the number of hydrogen valleys in Europe, and we'll see later in the presentation what we mean by that. Then we have a regulatory framework, the so-called gas package that was released in December last year, and currently we have 2 delegated acts that gives more information on how actually we're going to implement the gas package when it comes to hydrogen. And these 2 delegated acts are now open for consultation. The consultation we closed the 17th of June, if I will remember. And this is an invitation to all the stakeholders participating to this event also to participate and give feedback and help for the definition of the new of the final stage of the gas package. Then we have a series of important projects of common European interest. The so-called Hydrogen Alliance is selecting projects of this level that will receive important funding from the European Union and the member states in order to advance on the transition towards an hydrogen economy. We're working on standards, in particular with international bodies, and we are working on developing cooperation mechanisms with the member states and therefore the regions to accelerate this transition. And I will speak about this in the last part of my presentation. So we have also an R&I powerhouse mechanism. So we know that in order to produce such an amount of hydrogen, we need to continue to invest in research and innovation to bring down cost and at the same time increase efficiency to produce as much as possible green hydrogen in Europe. So that's why we need research and innovation still. The cooperation mechanisms are supported by Horizon Europe through, in particular, the partnership, the Clean Hydrogen Partnership, that is a part of the new set of partnerships under Horizon Europe. We have also the partnership of focusing on the Clean Energy Transition Co-Fund, where there is the cooperation with the member states can increasingly support specific projects across the EU to support the transition. And then we have specific clusters in Horizon Europe, like for instance, Cluster 4 and Cluster 5, with dedicated research opportunities, funding opportunities for hydrogen. As part of these mechanisms, we have also the European Innovation Council that has a focus on hydrogen, the KIC Energy that also will look at hydrogen. I just mentioned Power EU. I also mentioned the Green Deal, and as part of the Green Deal, we had last year also dedicated call exactly to accelerate the hydrogen productions. And there's at the moment 3 projects that are developing 100 megawatt electrolyzers in Europe and should come up with some initial results by 2024. We have also the European Research Area dimension with 2 specific pillars, one on hydrogen with the development of a pilot project on hydrogen. I will explain what I mean by that, and the SET plan, so the Strategic Energy Technology Plan revamping mechanism. This is where the European Commission and the member states will work together towards developing a path looking at new technologies for the energy transition. And then we have the international dimension supported with the work we do through mission innovation, and in particular with the Clean Hydrogen Mission. I mentioned before hydrogen valleys. Hydrogen valleys is one of the mechanisms that the Commission is looking at to support transition across the entire value chain. Hydrogen valleys can have different sites, can fit the local needs, and there could be a port, could be an airport, could be in a valley, could be in an island. So the concept is extremely flexible, but there are some key elements that need to be respected. So an hydrogen valley needs to integrate as much as possible the different components of the entire value chain across hydrogen. It needs to cover different sectors, transport, a specific industrial need, housing needs. So it needs to cover different areas, different applications. Then will be part of a rolling up concept. So more will have hydrogen valleys across Europe. At the moment, there are 23. There's a specific slide on that. And we want to double this number again, at least to 50 hydrogen valley by 2030. We have the acceleration dimension, thanks to Repower EU. And in fact, Repower EU will give more budget next year for hydrogen valleys. And then we have the cooperation with the member states, where also we're starting discussing how to develop and support more hydrogen valleys. This is a slide summarizing quickly the different archetypes of hydrogen valleys. We can have a small one, a medium scale, or a large scale archetype. What is interesting is that they really support and give answers to local needs. So that's why the collaborations with the regions become critical in the accelerations towards the deployment of hydrogen valleys. These are some key elements that I mentioned before. So the scale of the valley, they need to cover the value chain, supplying more than a sector. And the fourth one is the geographical aspect. When I say looking at specific needs, means that the hydrogen valleys have a strong geographical dimension. And we're looking at ways also to link those valleys between themselves and create hydrogen corridors in Europe between the different valleys. So this is a slide I was referring before. At the moment, there are 23 hydrogen valleys in Europe, and we would like to see more and more of those valleys in the eastern part of Europe and in the southern part of Europe, to make sure that this approach is fully fledged across the Union. And in order to do that, we have the funding provided by the joint undertaking. There are currently 2 calls out to support hydrogen valleys, a large one and a small one with deadline in September. And Repower next year will give an additional 200 million. I mean, this is the plan. We're still discussing this in order to support the deployment of new valleys in Europe. We are doing this as part of a general commitment that we have at the European level to meet international global targets, and as part of the work we do with the Clean Hydrogen Mission, as part of mission innovation, we contribute in Europe to that specific target. So mission innovation want to achieve at least 100 new hydrogen valleys in Europe by 2030, and European Union would like to substantially contribute to this target and have at least 50 located in the EU. These slides are related to the cooperation mechanism that the European Union has put in place with the member states in order to accelerate the energy transition. So we have the European research area, in particular the Council asks the Commission and the member states to work together on specific actions, and we develop a specific action on hydrogen that is called green pilot on green hydrogen. And as part of this action, we have also the revamping of the SET plan, the Strategic Energy and Technology Plan. So the ERA pilot on action on hydrogen brought together different member states that work across different thematic blocks in the area of transport, productions, and market simulation, and they came up with the strategic research agenda that was presented recently at a final conference at the 16th of May 2022, and now we are towards the deployment phase, so put in practice all the different activities that are mentioned in this strategic research agenda, not to be confused with the strategic research agenda of the joint undertaking, that is the partnership that we have on clean hydrogen. Same name, complementarity, but two different documents. So the ERA pilot on green hydrogen is an excellent example supporting cooperation between the EU and the member states on a specific issue, the transition towards an hydrogen economy. And the member states will be very much in the driving seat, and together with the member states also the most advanced regions that want to transition towards an hydrogen economy. So this will set the framework for a number of initiatives and support links and joint activities. From the European Commission perspective, our contribution to this process was the development of a strategic staff working document that surely you will be aware of, and as we tried to divide the staff working document into 5 main areas of activities. So the development of an era for uptake new ideas to the market, accelerate the process and get new ideas to the market as soon as possible, and we're going to do this with open innovation test beds to support and test new technologies. We will have an era for data, so the setting up of a EU Clean Hydrogen Observatory, building on the current observatory but making it bigger and reaching out more stakeholders, and where also member states and regions can feed into and contribute to the development of the observatory. We will have an era for skills. There's a macro project supported by Erasmus+. It's called Alliance for Skills, and this project will support that training and that planning needed to support all the skills we need as part of the transition to the hydrogen economy. The staff working document is also mentioning the hydrogen valleys, what they are, is providing a definition for them, and what the Commission sees as a way forward in terms of bringing them as part of a network and connecting the different valleys. And then we have a specific area on supporting and reinforcing the international cooperation, but always in the framework of mission innovation. The SET plan is the second component of the cooperation mechanism. So the SET plan is a way to support the dialogue between Europe and member states in defining what specific technologies needs attention to support the transition. And as part of the cooperation activities, we have also an ERA forum that used to make the point and understand where we stand and what is still needed. As part of the revamping process of the SET plan, we are including also hydrogen, that it was not there. The SET plan was developed 10 years ago, so hydrogen was not mentioned in there. Now in the revamping process, we're bringing hydrogen as part of it, and so we will have an additional cooperation mechanism to be used. And with that, I would like to thank you very much for your attention. I'm open to any question, and only working together, and in particular with the cooperation between EU member states and the regions, we can achieve the ambitious goals of the energy transition, where hydrogen will play a key role. Thank you very much.
Very much for this presentation. We'll be taking a question at the end of today's session during the Q&A session, so please stay with us till that moment. And now we are moving to the 2030 Polish Hydrogen Strategy, and this will be presented by Piotr Kropiński, Head of Hydrogen Economy and Innovation Unit at Electromobility and Hydrogen Economy Department at the Ministry of Climate and Environment. So let's connect with our next speaker.
Can you hear me?
Yes, we can hear you clearly, so if you can hear us as well, please do start.
Okay, I just share with you my presentation, and okay, I just wanted to confirm if you see the full screen side, or now it's better. So thank you for the opportunity to talk to you. I'm really glad I'm invited, and I also I was very interesting to listen the predecessor, Luca Polizzi, and it was very interesting, especially on this valley, hydrogen valleys. And I want to make sure that we are keep in touch with Clean Hydrogen Partnership to soon introduce Polish hydrogen valleys into the European system. I wish I were with you in person, but we really have a lot of work working on implementation of Polish hydrogen strategy. So if you have any questions, just ask me after the presentation. Also see my contact details at the end. Let's start. I will try to keep my presentation short. Have limited time. So first of all, this is the current situation of Polish hydrogen market. We are up to date third largest hydrogen producer in the European Union. Although it's a grey hydrogen produced from fossil fuels, so I'm not really satisfied with this. We want to achieve carbon neutrality similar to European Union, and we need to go through the transition period to change the currently functioning installations into the electrolyzers, mostly electrolyzers. What's important, we produce most of the hydrogen on the site where we use it. So we don't have any market actually, because we are not able to store hydrogen and to send them through the network. So there's lots of things to work and to regulate, but we are ambitious and we want to be an important player on the hydrogen market in the future. So to achieve this, we prepared the hydrogen strategy. It's adopted by the Polish Council of on the 2nd November in 2021, with the time frame till 2030, and the priority sectors are energy, heating, industry, and transportation. We set up 6 objectives. I will list those just straight away and describe them a little later. The first one is hydrogen use in energy and heating sector. Then second, hydrogen as an alternative fuel in transport. Third, industry decarbonization. 4, hydrogen production. 5th, hydrogen transmission, distribution and storage. And 6, stable regulatory environment. So objective number 1, what's important here that we are strongly working on to change our energy mix, and in 2030, the energy policy stated that we will produce at least 32% of electricity with renewable energy sources. And what is important, we won't get any significant amount of renewable hydrogen without renewable energy sources. This is the interconnection that we see, and we will invest not only in hydrogen but also in renewable energy sources, especially in the offshore wind farm that will produce more energy we could use to produce hydrogen via electrolyzers. So important is also that we can use hydrogen not only as a chemical stuff, but also as energy carrier, and we can also it's a way better to store energy in hydrogen than in battery, because we don't lose this energy, and we can easily change them into energy using fuel cell technology. It will stabilize the energy network and energy sector in future instead of natural gas. Now, objective number 2 is hydrogen as an alternative fuel, and we see those actions at the top that we will cover, and the key performance indicators at the bottom line. So we want to invest in public transportation. So not only support the producers, but also build the demand side. So in 2030, we want to have at least 1,000 buses on the Polish roads. At least 32 hydrogen refueling stations, also hydrogen trains and locomotives, and we will support research and development in maritime and aviation transport. Objective number 3 is the decarbonization of industry. we keep in mind the greenhouse emissions must be lowered, and some part of industry may be decarbonized only via hydrogen. Objective number 4, we will, despite the European strategy, we want to support not only green hydrogen or renewable hydrogen, but also low carbon hydrogen production. It's important we need to stay at least in a specific period of time colorblind. It means we will not see hydrogen colors, but we will look how much emission do they produce, and support those productions that are low carbon productions also. It means also steam reforming with the usage of carbon capture and storage technology. Of course, to have a market, we need to have a network, also the main players on the market, like operators, a possibility to store the hydrogen, and to finally to distribute them to the users. And the next slide, this is the legislative package. We call this Hydrogen Constitution. It consists of 2 pillars. First is the framework for hydrogen market, and we are working hard to prepare this document for public consultations soon. I think in autumn this year you will have the opportunity to discuss this project. And the second pillar is the law that will support hydrogen, especially green hydrogen production. It will be prepared later this year, probably beginning next year. Those legislative package are the part of National Recovery Plan. It's the priority for the ministry, and a lot of it's important project, and it will be delivered soon. You can see also the strategy indicators, but I will skip this slide because I think I am running out of time a little. So the implementation of strategy roadmap, we are in 2022. As I said, we are working on the regularity to make a regular work for hydrogen. But parallelly, we are also working with European legislative package, so-called decarbonisation package, to make sure that it will not harm the already existing Polish market, Polish hydrogen producer. We also conducted a Polish hydrogen sector deal. We strongly believe that the dialogue with the market is important to prepare good legislation. This is a key instrument to implement the Polish hydrogen strategy, and we stay in touch with the representatives of public sector, academia, entrepreneurs, and business. Okay, Recovery and Resilience Plan. As you probably have heard, it is approved by European Commission this month, and we will have a 8,000 million euro earmarked for hydrogen technologies. Those are implementing by milestones. Some of the milestones are already achieved, like the entry into the force of the regulations for hydrogen as an alternative fuel for transport. And some of them are the part of so-called hydrogen constitution. And the last slide, as you see, we also preparing the funding scheme to distribute the money that are earmarked in Recovery and Resilience Plan. It is prepared with National Fund for Environment Protection and Water Management. So together we're working now to actually close the program soon and launch them. It is divided in three parts. The first is investment in hydrogen technologies and accompanying infrastructure. Second is important project of common European interest. Those will also get subsidized. And the last one, support for innovative transportation units based on hydrogen. In this third part, it is mostly research and development projects. Okay, so thank you for your attention. I really appreciate if you will have any more questions, just contact me and I will be glad to hear you and to answer your questions. Thank you. Thank you.
Thank you very much for being with us today, ladies and gentlemen. Now our next speaker, Andrzej Czulak, PhD, leader of Polish cluster Composite Technologies, will present the composite innovations in hydrogen.
Thank you very much for the introduction. Ladies and gentlemen, my name is Andrzej Czulak, and I am a leader of the Polish cluster of the Composite Technologies. And I would like to give a presentation about the composite innovation in hydrogen. I would like to start by explaining why is hydrogen so important. Because hydrogen will play an important role in the European future energy mix. Hydrogen will meet 20 to 30% of European countries' energy needs, and also helps the countries reach its target of net zero emission by 2050. Hydrogen boosts, of course, EU countries' economy and increasing the energy security. Hydrogen is a good way to move, transport, and store of energy from where it's created, where it's produced, to where it's needed. If the energy for the production process of hydrogen come from renewable sources, it is green hydrogen. As the only byproduct of hydrogen use is water vapor, green hydrogen could be a game changer. And if we compare the energy storage potential of individual technologies, from the flywheel to batteries, compressed air, pumped storage power plant, and power to gas, we can see that two technologies have a great potential. First, power to gas with hydrogen, and second, power to gas with SNG. Power to hydrogen, and there we're using electricity to produce hydrogen. This is called electrolysis. And power to gas, SNG, methanation, power to methane, and we using the hydrogen produced in the first stage, we produce the energy to produce methane. Methane has even higher storage capacity value than hydrogen, despite the fact that hydrogen has a higher energy density than natural gas. But to green methanation, we need hydrogen, preferably, of course, green hydrogen. Based on the Hydrogen Europe 2020 report, I just wanted to give few facts about the hydrogen. Hydrogen is mainly produced from the fossil fuels. About 6% of global natural gas production. Hydrogen production produces over 800 million tons of carbon dioxide today. We have in Europe more than 450 plants producing a total of 11.5 million tons of hydrogen per year. Poland is the third largest producer of the hydrogen in Europe, producing 1.3 million tons of hydrogen per year. The information from 2020, according to the Hydrogen Europe report. And why are composites dedicated for the hydrogen? Because the low density of the hydrogen forces the hydrogen to be compressed and stored under high pressure, because the low weight, mass, and high strength of the composite materials, and this makes composite an ideal material for pipes, storage tanks, and vehicle fuel tanks and vessels. Composite and polymer materials offer low gas permeability and high resistance to environmental loads. And for this region, hydrogen could create a step change across all industries, slashing emissions and fuel costs. It is also very important to remember. With the development of the hydrogen fuel cells, onboard hydrogen storage technology with safety, efficiency, and economy has become a fundamental part. Low cost, lightweight, and good safety performance are required for onboard hydrogen storage tanks or vessels. Polymer or composite high pressure storage tanks have been recognized as an efficient solution that could address this problem. That is why the activity of the Polish cluster of the composite technology is important in this process. We are a strategic cluster, and we are granted with the status of national key cluster, and now we have support not only from the regional government but also from the state government. Currently, over 100 companies and institutions dealing with the composite materials and technologies are associated in the cluster, and their number is constantly growing. At the end of the last year, companies and institutions belonging to the cluster employed in Poland over 15,000 employees, and total income from sales of all members is almost 5 billion of zloty. To the cluster belong entities producing components for the production of the composite. The companies produce the machines producing the composite structure. They are also design offices, research center, but also institutions and companies dealing with the repair and recycling of the composite structure. We are located in Krakow, in Małopolska Region, And this is the real cultural heart of Poland. Here you can see some logos of our companies and institutions, and in the whole of group of these companies we have also 12 research institutions dealing with the composite materials and structures. As I said before, hydrogen could create a step change across all industries, slashing emission and fuel cost, but the problem of transporting and storing of the hydrogen is anything but trivial, because lack of standardization of the components for hydrogen transport and storage, different requirements of composite components for hydrogen transport and storage depend of the region, country, and major player, different manufacturing technologies in different European regions, lack of standardization in the production, monitoring, and verification of the composite components, and current production cost for different types of hydrogen. For these reasons, the Polish cluster of the composite technology, together with the Instytut für Leichtbau und Kunststofftechnik of Technische Universität Dresden, from Sachsen, from Saxony, and Małopolska region, initiated a project which became the base for the creation of the hydrogen pilot project. This application has been made possible thanks to the involvement of many regions, but the greatest thanks must go to Małopolska, Saxony, Lombardy, Slovenia, and Wales. This hydrogen pilot addressed the following areas in hydrogen: hydrogen production and production technology, plus standardization, business diversification into hydrogen and commercialization of products, hydrogen application opportunities for mobility, for domestic and for industrial energy usage, hydrogen distribution and export, hydrogen skills requirements, and knowledge creation and translation. The following speaker will definitely talk about these areas, and I will present the first area in the following slide. Other regions participating in the pilot should be also mentioned, like Lower Saxony, North from Portugal, Gavelborg from Sweden, Aragon, Asturias, and Galicia from Spain, Scotland and Wales from UK. The coordinators of the pilot disaster, there will be Lombardy, Małopolska, and Slovenia. On the right side of the slide, you can see also the research institutions, industry, associations, academia, and companies interested in being involved in the pilot's objectives described in the proposal region. Of course, the list is not closed. We look forward also for your participation. Now, I would like briefly introduce demo case Hydrocomp. It concerns standardization of production, hydrogen pipelines and vessels for storage and transport of gases, including hydrogen under high pressure. Under this action, it is planned to create a guideline for prototype automated production line for high pressure pipes, fittings, and composite vessels for the storage and transport of gas, of course, including hydrogen. The results will be jointly created set of standards, requirements, and conditions applicable across European regions. We would like to carry out analysis of the current state of art, comparison of the technologies for manufacturing of composite elements in the European Union countries. We would like analyze this of barriers to the introduction of high pressure solution for pipes, fittings, and composite vessels in European Union countries, conduct comparative studies between current solutions and those planned in the multi-material approach, determination of the current performance level of the installation according to the region or utility level, exploring the potential of innovative composite technologies for the production of high pressure elements, definition and integrated monitoring system for production and operating of composite fittings, pipes, and vessels, standardization of the solution and creation of the virtual technological line project, allowing for the economical and repeatable production of high pressure elements of high pressure pipes, fittings, and of course vessel, implementation of development solution through the European Union. And after the project, we will start this dissemination of the results, jointly developed science to business and business to business website, and supported event on hydrogen technology. And on the end, we will introduce European project based on the elaborated results. As presented, the action plan is divided into 4 main activities: data collection, analysis, definition and implementation, and dissemination of the results. The first action are already being implemented. For example, through our partnership with Małopolska Region and Composite United. This is the cluster from Germany. We are already organizing joint industry events like now this conference of the composite materials in the hydrogen technology, but also a trade fair and conference, Composite Expo in Krakow, and online German-Polish Innovation Day are planned for this autumn. And the next year, as a strategic partner of Lightweight Convention, short LightCon 2023, we invite you to Hanover Messe for trade fairs and for conference. And this will be also time for presentation of the results of our project. Finally, I will say also that several companies in our cluster are currently producing composite vessels and pipes for hydrogen transport and storage. For example, Wit Composites, Amargo, and Plaston P. Thank you very much for your attention. If you have any question, please contact me. Below, you can find my contact details. Thank you very much one more time.
Thank you very much for this presentation, and we are moving to the in-house presentation here on this very stage. Grzegorz Jóźwiak, the Director of Alternative Fuels Department at PKN Orlen, will present the hydrogen strategy at the Orlen's Group. Please join me on the stage.
Hello, good afternoon. First of all, thank you for invitation. This is quite important for me, for PKN Orlen, to be here, because in Krakow we are going to start our first hydrogen mobile station. So quite important step in hydrogen direction, in the stream of hydrogen for transportation. And today I would like to present generally two main streams. First, this our hydrogen strategy in Orlen Group, and I would like to also present a few ongoing projects connected with hydrogen. And I have question about the pointer because doesn't working. Oh, okay, now it's okay. Regarding Orlen Group strategy, we also add 2 years ago hydrogen as a one stream, as I investing in the future stream, and we saw in hydrogen quite important direction regarding the decarbonisation of our existing asset and decarbonization of transportation. And this year we announced dedicated hydrogen strategy. It was prepared by our internal team and generally focus on covering the full value chain of hydrogen. And main approaches of this strategy are connected with diversification of sources of hydrogen. So we're focusing on projects connected with production low zero emission hydrogen from different sources, from electrolysis process based on renewable electricity, as well as hydrogen produced from technology from municipal waste, waste to hydrogen technologies, and from biomethane. And also we look for our existing assets of production of hydrogen from natural gas, so this gray hydrogen, and we also address this topic in CCS, CCU technology addition in our strategy. And what also is important, that second approach for our strategy was that we have from one hand refinery and petrochemical assets which need to be decarbonized, and on the other hand we strongly develop this renewable electricity direction, the energy segment, and generally we see big synergy between two directions. First is connected with stabilization of renewable electricity production by offshore wind farms, for example. So the hydrogen help us to maximize the installed capacity utilization. And on the other hand, this hydrogen can be utilized in our refinery and petrochemical assets as a decarbonization path, but also today this is also important direction from fossil fuels decreasing consumption, so this is additional value today. And our strategy has 4 pillars. First is hydrogen implementation in transportation. We focused in this area on heavy duty transport, municipal transport. Of course, we also think about projects connected with air transport or projects with sea transport, but in this area we see more synthetic fuels as a fuel in this area, which will be produced based on green hydrogen. Second pillar is refining and petrochemical decarbonization, which I mentioned before. Industry and energy. In this area we see this synergy between the renewables and hydrogen production, especially close to the big projects of offshore wind farms production. So there is opportunity to produce high volume of hydrogen, and in the next decades this hydrogen also in energy segment will be utilized as a source of energy, for example in heating area. And fourth pillar is dedicated for R&D. So we would like to develop projects connected with hydrogen, also with external partners. So a few words about KPIs. Till the end of this decade we would like to install 540 megawatts of hydrogen capacity produced from electrolysis process and waste to municipal waste reprocessing technology. 50 of hydrogen produced from our assets will be low and zero emission. Today we produced about 340,000 tons of hydrogen, so we are going to decarbonize half of this number. And the impact of this strategy for CO2 emission is 1.6 million tons of CO2 reduction. And main goals in transportation, utilization of hydrogen for transportation is more than 100 hydrogen refueling stations, which will consume in 2030 about 19 KT of low zero emission hydrogen. Budget for this strategy, dedicated budget is 7.4 billion zlotych. And also we are going to try to get some kind of subsidy fundings just to which just help us to break the entry barrier, because this entry barrier, taking account the capex, taking account also this full infrastructure of hydrogen, is extremely high. So we also see and participate in different programs on the level of Europe as well as country level. Regarding the ongoing projects, I would like to present few information about our first Polish hydrogen hub in Trzebinia, which produced automotive hydrogen laboratory of automotive quality, our project dedicated for transportation, clean cities, hydrogen mobility in Poland, and few words about our flagship project, Hydrogen Eagle. So taking account the project of production of hydrogen with automotive quality, we have already finalized this project in our daughter company Orlen Południe. This project is located in biorefinery in Trzebinia, and the hydrogen will be utilized in for transportation goals, and the, let's say, first mobile hydrogen station will be installed. This is part of this mobile hydrogen station. This will be installed here in Krakow, and together with colleagues, with fleet owners from Krakow, we will test in, let's say, few days. We will test this full value chain of hydrogen delivery. Also, what is important, that this hydrogen quality need to be really extremely high, taking into account the standard ISO 14687. So this is quite big challenge. We know that quality of fuels generally is very important. We have experience from standard fuels like diesel, gasoline, that this quality always need to be monitored, and we need to deliver this quality in accordance to standards. And in this case, we invest in hydrogen laboratory, which is located also in Trzebinia, and was coordinated and implemented by Orlen Laboratorium. And of course, this is not only equipment, but also competences of people. So now we are able to analyze 17 parameters with this, with accordance to this ISO standard, and now this laboratory is also available for additional testing. This is example of clean cities, hydrogen mobility in Poland. This is, let's say, program which we submitted to CEF, Connecting Europe Facilities funding, and we get for this project about 2 million euro funding, and it cover hydrogen production hub in Włocławek based on existing electrolysis process, and 3 hydrogen refueling stations in Poznań, Katowice and Włocławek, plus 11 tube trailers for distribution of this hydrogen. And this project is under realization. We expect that we start this project next year. Also, this is important that also we will have standard HRS stations, quite big stations with hydrogen standard 350 bar, as well as 700 bar dedicated for automotive. And last project, this is last but not least, this is our flagship project connected with building full infrastructure in Central Europe. This project cover full value chain of production of hydrogen in, let's say, distributed way. So we are going to install hydrogen hubs similar to this one in Trzebinia, but based on different sources of hydrogen, as I mentioned at the very beginning. So part of this hydrogen will be produced from electrolysis processes, but also from municipal waste reprocessing. And this project now is on, let's say, European Commission level for and waiting for notification. This is quite important project because the IPCEI program, so projects connected with important for European, let's say, impact, not only for locally for Poland or Czech Republic, but this importance we show as building some kind of corridors, hydrogen corridors, north-south corridor, and participate in some few initiatives with other partners. In Poland, we are going to install in this project 54 HRS, in Czech Republic 22, and in Slovakia 26 hydrogen refueling stations. So this is, let's say, main information which I would like to share with you. So summarizing, we would like to be, let's say, to be in position as a leader in Central Europe regarding the implementation of hydrogen technologies. We building the multi-energy concern, so this is quite important also to develop these new streams, new business lines connected with low zero carbon technologies. And hydrogen is part of that. We announced the dedicated hydrogen strategy, so this is also quite important direction for us. We have also quite ambitious goals. These 100 hydrogen refueling stations, 540 megawatts of installed capacity of hydrogen. This is really a big responsibility, but also this is big opportunity to let's say, change the economy for low zero emission. And these examples which are present, the first project which cover full value chain of hydrogen from production to HRS utilization. We are going to start this project in few days, and also it is supported with this laboratory, hydrogen laboratory. So from my side, this is everything. Thank you very much.
Thank you very much for this presentation. Grzegorz Jóźwiak has mentioned the automotive hydrogen as an element of transformation of Orlen Południe into biorefinery, and Grzegorz Semeriak will now present this subject in details, being the Director of Technology and Development at Orlen Południe. Let's find out whether we are already connected with our speaker. Hello. You are already online with us. Can you hear us?
Okay? Yeah.
Can you hear us?
Yeah, I can hear you.
And we can hear you as well, so the stage is yours.
Okay. Thank you for invitation. Good afternoon, ladies and gentlemen. Thank you for invitation for this conference. I'm glad that I can present some aspects connected with hydrogen, but of course I will present some project why we transform our company, daughter company of PKN Orlen, to biorefinery, and what is the role of the hydrogen. Not exactly in the colors at this moment, but to develop the market on the Polish market. So I will present now. Okay, so as I said, we start the strategy transformation of Orlen Południe from crude oil proceeding to biomass for sustainable products. First of all, we start to increase the capacity of biodiesel plant, because we are the greatest producer of biodiesel in Poland at this moment. In the next step, we plan to implement production of biodiesel, which will refuel your cars from used cooking oil. And I suppose that the final capacity of biodiesel at the end of 2023 will be more than 300,000 tons per year. Another steps in developing of Orlen Południe is a construction of bioethanol complex. We start this project in EPC formula in 2022, few months ago. And we plan to finish the investment in the second quarter of 2024. So it will be the next step in implementing alternative fuel on the Polish market at this moment. The small project, but very high potential of transformation from crude oil proceeding to use the biomass and produce the bioproduct, the sustainability products, is lactic acid. We start in the laboratory, and now we on the pilot scale in the Trzebinia, and we plan to implement the capacity circa about 5,000 tons per year. Poland now is the greatest importer of lactic acid in Europe. So we suppose that at the end of 2024, we will have a circa about 75% of Polish market. Another project connected with transformation of Orlen Południe to biorefinery, and of course to use as raw material biogas for production of hydrogen, is a biogas plant in Orlen Południe. We start this project 2 years ago. Yes, 2 years ago, and we have some on the project scale some biogas plant in our structure. We produce circa about 50 million cubic meters of biogas per year, and now we plan to invest some solution to produce the biomethane and then to produce the CNG or LNG. It's strictly connected with localization, which solution we'll have on this plant. Propylene glycol, the project which we final at the end of 2021. Why I talk about it? Because this is the core project connected with transformation of our company. In the standard way, the propylene glycol is produced from the crude oil use the raw material as propylene oxide. In our complex, we use the glycerol, which is produced in the biodiesel plant, which I present you at the first slide. In this plant, in the propylene glycol complex, we used the hydrogen for the hydrogenation of glycerol. So as you see, we implement some solution and some synergy between the project, and we can produce the final alternative fuel as we talk today in this conference. As Grzegorz Jóźwiak said before a few minutes ago, Trzebinia now implemented to the market some volume of the automotive hydrogen, the hydrogen, we call it 5.0. This project is, as I said, the synergy between the project propylene glycol production. We start this investment in the second quarter of 2020. The implementation of this unit was from 2020 to the first quarter of the 2022. We made test run for this unit, and I can be sure that we can produce circa about 4 million cubic meters of hydrogen, the highest quality of this product. It's when you calculate to the kilograms or to the tons, it's at circa about 360 tons of fuel. This technology is connected, of course, on the very well-known technology as steam, natural gas steam reforming at this moment. Yeah. So in the first step, Orlen Południe would like to implement the volume of some volume of the hydrogen 5.0 to the market, not strictly connected on the colors of it. At this slide, you see the unit. On the first one is a standard steam methane reformer. On the small one, on the right side, you see our unit with absorption. Is a unit responsible for production of the highest quality of hydrogen. Why I talk about the biogas plant project? As Grzegorz said in a few minutes ago, we plan to implement the production of hydrogen from biomethane. So this is a still potential that this hydrogen will not have a gray color, will be low emission hydrogen. And in the next step, we plan to implement on the hydrogen unit CCU or CCS unit for CO2 capturing. So if we use the old one technology as the methane steam reformer and use the alternative raw material for produce the hydrogen, in the near future, this hydrogen will be green as hydrogen from electrolysis. Frankly speaking, what we achieved, of course, this is very technical, but as you look at the market, everyone said we would like to buy the buses, we would like to buy the civil cars based on the hydrogen fuel. Of course, if you want to buy, there are not hydrogen fuel at this market at this moment. So this is something like a circle. Everyone said a lot of the hydrogen, but this hydrogen to the beginning of 2022 do not exist. Yes, so I would like to present you that, as Grzegorz said, that we start at the beginning of this year for production of hydrogen 5.0. So according to ISO norm, you see that the hydrogen fuel index is 99.97. Our results at this moment in Trzebinia is 99.999, or second one 99.9997. The purity of this fuel is very high, so we start implement this fuel to the market, of course, with the cooperation with PKN Orlen at this moment. Another project strictly connected with the production of hydrogen and distribution and then the selling, the mobile station refueling station. Grzegorz present you the photos from this refinery station. We have some pictures of it. So in the near future, we will implement the hydrogen 5.0 to refuel the buses in Krakow. So as you see, now the hydrogen is not a fantasy, it's a realistic alternative fuel on the market. So if you have any question, please ask or contact me directly. Thank you very much.
Presentation, ladies and gentlemen, please let me look at the clock because we are a little bit behind the time, but we would like to start the next session on point. So we'll have a short coffee break for everyone to refresh, and 3:15 we'll be meeting here for the next round of the presentations. I hope that those that are watching us online will also stay with us, and with the same punctuality will join us back.
Małopolska is where culture, history, and tradition reign. We enrich the values we inherited from previous generations with innovation. About 10,000 new companies arise here, including tech startups. We develop advanced ICT and business technologies. We set our goals high, especially with regard to nature, an indispensable part of happy life. Pursuit of perfection and the highest quality of production are our trademarks. It's in our DNA. The tone comes from the top. Thus, we inspire others with our creativity. We create a space for ideas to bloom. We develop our passions. our imagination reaches the stars and our dreams come true. We can be your collaborators, business partners, and friends. Małopolska. We develop innovation.
Co by było, gdybyś wyruszył w podróż do niezwykłych miejsc, przeżył wspaniałą przygodę i odkrył dla siebie coś wyjątkowego? Zachwycające miejsca, które sprawią, że poczujesz się wolny i zaczniesz patrzeć na świat zupełnie inaczej. Co by było, gdybyś znalazł się w miejscach, o których słyszałeś, ale nie miałeś okazji ich odwiedzić? W których poczujesz spokój, radość i chęć do działania. W miejscach, gdzie natura współgra z człowiekiem, pozwala zwolnić tempo i dać sobie prawo do relaksu. A gdybyś przeniósł się do krainy niezapomnianych emocji i pozytywnej energii, które na długo pozostaną w pamięci? Co by było, gdybyś na co dzień mógł obcować z kulturą i sztuką, które kształtują wrażliwość i inspirują w codziennym życiu? Gdybyś zobaczył to, co zachwyca swoim pięknem i przypomina o sprawach w życiu najważniejszych. Co by było, gdybyś znalazł miejsce, w którym możesz być sobą? Gdzie czujesz się szczęśliwy i bezpieczny? Co by było, gdybyś mógł nazwać to miejsce domem? Co by było, gdybyś został tu na dłużej?
Małopolska is where culture, history, and tradition reign. We enrich the values we inherited from previous generations with innovation. About 10,000 new companies arise here, including tech startups. We develop advanced ICT and business technologies. We set our goals high, especially with regard to nature, an indispensable part of happy life. Pursuit of perfection and the highest quality of production are our trademarks. It's in our DNA. The tone comes from the top. Thus, we inspire others with our creativity. We create a space for ideas to bloom. We develop our passions. our imagination reaches the stars and our dreams come true. We can be your collaborators, business partners, and friends. Małopolska. We develop innovation.
So I would highly encourage you to take your place at the audience. And yes, we've been joined by our first speaker for this second round of the presentations. Jan Filip, Project Manager, Export Promotion Cooperation from Saxony Trade and Invest, is now willing to provide us more information about the Saxon competence of hydrogen technology. I hope you can hear us. If we could also hear.
I hope you can hear me and see the presentation.
I think we have to volume you up, and I'll be happy to hand over the stage to you. So I think it's the time for a presentation.
Thank you very much. Dear ladies and gentlemen, kind regards from the beautiful city of Dresden. I'm happy to hear about your interest in the topic of hydrogen, as well as the situation of hydrogen here in Saxony. And as already mentioned, my name is Jan Philipp. I work as a project manager in the sales, promotion and cooperation department of Saxony Trade and Invest. And in the next 15 minutes, I would like to give you a compact overview on the Saxony competencies in hydrogen technologies. So for those who have not yet had any contact with Saxony Trade and Invest, I would like to briefly introduce Saxony Trade and Invest in 3 sentences. Saxony Trade and Invest is a state-owned economic development agency of the Free State of Saxony, and it sees itself as a door opener, bridge builder and networker for companies as well as investors and cooperation partners worldwide. The work of Saxony Trade and Invest is based on 3 pillars. So we talk about the first pillar is global promotion of Saxony as a business location, and of course the acquisition of new settlements, maintaining contacts to the industry networks and the early identification of technology trends. And the last pillar is to support Saxon companies in the development of domestic and foreign markets. So as you see, the topic of hydrogen affects nearly all of these 3 mentioned focal points of our work. So I would now like to present the Saxon competencies in the field of hydrogen technologies. Hydrogen is seen as an essential element in the decarbonization of the energy industry and is considered as an alternative to fossil fuels. So we have heard a lot today about strategies and the importance of hydrogen. So now I would like to focus a little bit on the strategy. So the World Energy Council has identified that over 50 countries yet have adopted national hydrogen strategies, or they are supporting national hydrogen projects. By 2025, it is expected to have around 80% the global GDP. So all countries representing around 80% of the global GDP, that they have their own hydrogen strategies implemented. And the goals are very similar. Yeah? So we talk about reduction of greenhouse gas emissions, expansion of renewable energies, and diversification of energy sources. Furthermore, all of these countries, they see opportunities in economic growth through the creation of new jobs, technological development, and the additional revenues along the entire value chain of the hydrogen economy. And also, Saxony has now adopted its own hydrogen strategy beginning of this year, so shortly before China launched their strategy, and Saxony is already well positioned in this area. Saxony has a very high density of universities as well as research institutions, and there are large numbers of actors who can initiate implement projects, who can implement and offer new solutions for the hydrogen economy. And in addition to the already mentioned goals of the hydrogen strategies of many states, the Saxon hydrogen strategy also contains to establish and foster a strong hydrogen economy covering the value chain, starting from R&D to H2 generation, to the usage of hydrogen, and of course to the trade of hydrogen and the infrastructure. It is a really important goal to support the industry to scale up the production of the required hydrogen technologies for international market, and to establish and safeguard a sustainable infrastructure to enable and furthermore to enable the development of an hydrogen economy in structural change regions and industries, like we have them in Saxony, for example, the old coal mining regions, but also automotive industries or suppliers who are currently working in the internal combustion engines. Yeah. In order to achieve these goals, a large number of measures were already initiated in 2021 before the Saxon hydrogen strategy was published. This was possible because of the Free State of Saxony has been actively supporting this topic of hydrogen for years, and in addition to a very well developed research landscape, companies from the business sector can also demonstrate established solutions along the hydrogen value chain. Universities as well as research institutes have developed cutting-edge technologies for the hydrogen economy, and one of the recent highlights was the presentation of the reference factory H2, an electrolyzer and fuel cell production of the future by the Fraunhofer IWU, which with several locations in Saxony. So recently at the Hanover Fair, you could learn about this really interesting project from Fraunhofer, which provides a design guidance and a modular system based on a quite innovative and specific optimized technology to allow an efficient and serial production of fuel cells and electrolyzers in an economical scale. Furthermore, there are manufacturers and engineering companies like Sunfire, Linde, FCP, and EDL that manufacture electrolyzers, fuel cells, as well as power-to-X solutions in industrial scale. This is supported by gas networks and operators, as well as gas trading groups that provide the infrastructure for the industrial users who have already committed to usage of green hydrogen or already use hydrogen within their processes. Another very interesting point in Saxony is HINCO. The HINCO is the hydrogen intermediary network company, and it is an important player for the European trade of hydrogen and hydrogen derivatives. And it is also located in Leipzig. the task or the goal of Finco is to mediate between long-term purchase contracts with suppliers of green hydrogen and short-term supply contracts for green hydrogen in order to secure the availability of green hydrogen in Germany or in Europe. If the achieved sales prices are lower than the long-term prices for the purchase of green hydrogen, the difference will be compensated by the German government. And therefore, a budget of around 900 million euro has been already allocated for this purpose. Yeah. Last but not least, there are very strong innovation clusters and networks in Saxony that are focusing on the application of hydrogen in the industry. This illustrated, or this is very good illustrated by the map shown on this slide. On the map, you can see a summary of the VDI showing selected innovation clusters and networks that are shaping the energy transition in Germany. 4 of these 23 selected networks or innovation clusters are located in Saxony or work cross-regional. The first one, number 9, is the innovation cluster H2 e.V. It is the Saxon Competence Center for fuel cells and hydrogen consultation on fuel cell technologies. They are also working cross-regional and want to cooperate on an international basis. And they have a very interesting project, for example, of an open source fuel cell stack and fuel cell system. So if you are a member of this network and this cluster, you can access to this information and you can further develop it, or you can use the information there already available. The network number 7, the Hypus e.V., is a cross-regional cluster in central Germany. The main goal is to achieve a profitable conversion of electricity into hydrogen, as well as its use in the industry. The network number 8, Energy Saxony, is the Saxon Competence Center of green hydrogen, and its main target is to attract new target groups for green hydrogen and to analyze and redesign business models for the industry. The 4th network that I want to introduce you is also very interesting. It is based in Lusatia. It is so also a cross-border network within Germany, but are also pretty close to Poland. This cluster is focusing on the development of a hydrogen economy in the former coal mining areas of Lusatia, and so are developing ideas and trying to implement them then within industry partners in the area. As a result of this very impressive existing base of industry, R&D and networks, we are happy that we have 5 IPCEI hydrogen projects in Saxony. So IPCEI means important projects of common European interest. So also this word was already mentioned today. And 4 of these projects I just want to mention. I want to mention in the next slides. The first project is the IPCEI project H2 Sahara, and it is by the Dresden-based company Sunfire, which is contributing its experience in the production of highly efficient and cost-effective electrolyzers to produce hydrogen from water and electricity, preferably from renewable energies, of course. Then we have Vetters from Olbernau and Voigt from Chopau, who are developing and installing production plants for fuel cells and air compressors for mobile applications. And also the company Vitesco from Limbach-Oberfrohna has expressed the interest of being part of this consortium. Yeah, through the European and national cooperation, it is the goal to create a European supplier network for components, plants, and hydrogen systems with this project. Another very interesting project I have learned of in Saxony is the project Hykero. It is a lighthouse project for a 42,000 ton per year power-to-X plant for the commercial production of green synthetic kerosene. So you can also say e-fuel or e-kerosene, green naphtha and green hydrogen. The key facts of the plant are that only green feedstock is used. So it means green electrical energy, water, and green methane. It is a fully integrated plant designed for the production of 42,000 tons per year. Green kerosene, around 14,000 tons per year green naphtha, and 15,000 tons per year green hydrogen. Yeah, and about 3,500 tons per year of the green hydrogen is available as a green transport fuel and for industrial customers in the area. Yeah. Furthermore, there is a complete reutilization of byproducts within the plant that ensures that zero CO2 emissions are produced during the production. Yeah. In general, this project saves over 165,000 tons per year of CO2 emissions compared to conventional crude oil-based products. Then there we have a very interesting technological showcase. It's called LÜV, and it aims to implement the entire value chain from generation, storage, transportation, and distribution to the end in the Leipzig region, and to the network, and to network it or to connect it with the European projects, cities, and the infrastructure. The core of these activities are IPCEI projects, which are the generation of hydrogen, so product projects for the generation of climate neutral hydrogen, as you can see it here. So this is one of the EDL projects that I have already mentioned, so it's part of this project. Then we have the system project that aims to find customers or applications to use green hydrogen. And last but not least, there's the transport, that means the creation of a transport ring around and for the Leipzig region, and integration of this transport ring into the European hydrogen infrastructure, so the European H2 backbone. Yeah. As a result, the region will be linked to the European hydrogen infrastructures and markets, which will lead into a climate neutral future with secure jobs and technological competence and a high quality of life. One or another very interesting lighthouse project on hydrogen is the Hydrogen and Mobility Innovation Center, which will be set up in Chemnitz. The Hydrogen Technology Center, HIC in Chemnitz, is intended to offer suppliers and especially small and medium-sized companies a high-performance development and test environment for hydrogen drives and components, in particular through unique hydrogen laboratories and for the extensive test benches. It is expected to be fully operational in 2027, and there is a significant amount of funding available for this project. Recently, there was a number confirmed of around 73 million euro for this project. Another interesting project, which is close to the border to Poland, so I expect that there will be also a very large amount of international cooperation, is the Hydrogen Lab in Görlitz. It is a research platform and research infrastructure on the Innovation Campus in Görlitz. The aim is to develop innovative solutions along the hydrogen value chain, and the benefits are synergy effects from the research competencies from the Fraunhofer Institutes and the Fraunhofer IWU and the Fraunhofer IWES. The research focus on is on the generation and storage of hydrogen, as well as the use of hydrogen in mobile as well as stationary fuel cells, especially for mobility and for supplying neighborhoods and industry sites. This is includes the of stacks and systems, microstructure analytics and diagnostics.
And I would like to ask you for the final thoughts as we are out of time.
Yes. So there's just a short summary. Sorry for this. So the hydrogen will, of course, play a key role in the decarbonization of industry. In Saxony, we have already a very good infrastructure and institutions who are active in this field. And we are, of course, we will continue to support on the entire hydrogen value chain.
Thank you very much for this presentation, and we are moving along for the presentation of our next speaker, Professor Mike Gude, the Chair of Lightweight Design and Structural Assessment at Technische Universität Dresden, will be now taking over the stage. Professor, do we have you already on the line?
Yes, Dzień from Dresden to Krakow. Maybe you can allow me to share my screen. I think Mr. Flip has to quit his presentation. Okay. Okay, I hope you can see my screen now. And thank you very much for the invitation and the introduction to this conference here. And today I would like to show some focal points here at the TU Dresden at the ILK, where we do research on hydrogen-powered vehicles, both on cars and in aviation. And please consider this presentation also to a welcome to further cooperation, which can be broadened up in the future. First of all, to give you a short insight into the University of Dresden, which is a similar size as of the AGH in Krakow. We have about 30,000 students here, and there are more than 8,000 people on board. And there are various study programs with students from all over the world. You can see here that there are more than 120 nations studying and working at our university. And this is a very heterogeneous and very fruitful cooperation in all different phases of scientists and young and older scientists. The TU Dresden itself has 5 main research priority areas, as you can see here. Besides the area health science, information technology, and culture and social change, there is especially the research priority areas where we are involved in. That is on the one hand material science and engineering, and especially the research priority area energy, mobility, and environment. That is the research priority area I'd like to talk about today, because there also the topic of hydrogen is located in, although it has also impact to the research priority area 3. Yeah, in this research priority area, you can see the topics, and very important here is the hydrogen research area. This is in line with the Saxony research strategy on hydrogen, as Jan Philipp just mentioned in his presentation. And there is a huge and whole comprehensive hydrogen strategy is also at the TU Dresden, focusing at different areas of hydrogen technology. I will show you this on the next slide. And to see the power which is done in this priority area, you can see there are more than two collaborative research centers running. There is different graduate schools running in this area. One of them is the Boysen Research Training Group with more than 25 students working on different areas of mobility, especially in connection also with hydrogen. So a very interdisciplinary research team looking for new solutions in the context of hydrogen, starting from the manufacture, the application, the storage, and also safety issues. Then there's also, last but not least, I would like to mention the joint hydrogen lab. There is also a new lab which was initiated 2 years ago, and that is in the area of Dresden, not only at the University of Dresden, but also in the context with the non-university research partners here, which are Helmholtz Center, which is Fraunhofer Gesellschaft, and also Max Planck and Leibniz Society. And all of them work together in this new in order to bring forward the technologies connected to hydrogen. The hydrogen strategy at the TU Dresden is multifold, as you can see here. It starts considering aspects in the hydrogen production, for example, membraneless electrolysis, but also it consists safety analysis, especially in the background of the German people who have not only good remembrance on hydrogen. If I remember on the Zeppelin in 1937, where excellent accident, and this is still aware, and therefore the safety analysis is accompanying very many of those research activities, considering the different systems containing a risk assessment and performing guidelines, especially with the focus on industrial applications. And so this is a very fruitful cooperation there. Besides that, there is power plant engineering, as you can see here, and also sensor development. And one big issue which I would like to focus on now is the area of mobility. Their work is going on propulsion concepts for e-fuels, but also for propulsion systems for different mobility systems, and especially for the aviation area, which I will focus on in the next slide. And last but not least, there's also a new center called HYLIC, focusing on liquid hydrogen applications. They work on liquefaction, transport and storage of liquid hydrogen, and also the whole system development and also re-evaporation. If we have a look at our institute and the activities in the area of hydrogen, then we can see this very nicely on this so-called hydrogen ladder, which goes back to Liebrecht Associates. And there they distinguish between unavoidable and uncompetitive hydrogen applications and research. And we consider not only the unavoidable area, but also the areas in the uncompetitive area in order to make them competitive in the future. And first, there is the whole area of stationary applications, which is primarily based on pressure-based storage of hydrogen. Besides this, there is the storage of in mobile applications based on cryogenic hydrogen, especially for aviation, the long-haul aviation and medium-haul aviation, and also in the area of shipping in long-distance trains and trucks. And besides this, we also have a very strong focus on the pressurized hydrogen storage and use in mobile applications. This starts both from small ships containing also short-haul aviation and also the automobile area, especially for trucks and other cars. The goal of us from the side of lightweight engineering is always the reduction of the weight and the costs, of course, of such storage systems, both for cryogenic storage and also pressurized storage. And there we aim a multi-material approach considering not only fiber-reinforced composites, which is a very important issue, but also considering multi-material designs made of metals and composites. And therefore, we have a number of projects running already. You can see some selected projects from the long list, distinguished in gaseous hydrogen storage on board and liquid hydrogen on board. There are different areas, for example, for different applications in small and medium-sized airplanes, where we consider different storage systems, for example, structured integrated storage systems or load-carrying storage systems as well. We also consider under-wing nacelles, where we can exploit the room due to aerodynamic and structural mechanics point of view, and exploit the available room there in a best way, also by adapting new designs of composite materials and also by developing new technologies in order to realize and technically implement these vessels, which can then be mounted, for example, under the Antares E2. Besides this, there's also a project running in the area of automotive area. There we always have a limited package, and therefore the storage systems the conventional storage systems have a conflict with a limited package room there, and therefore we develop new designs, so-called on a multi-cell design, in order to better exploit the package area also in the cars. Yeah, besides these gaseous hydrogens, there's also a number of liquid hydrogen storage projects running here at the TU Dresden. For example, considering also the handling and the safety for novel propulsion systems, also in context with fuel cell systems. And this is only a short list of running projects and competencies here. Let me consider three of these projects a little bit more in detail. First, I would like to start with applications in the automotive area. I just mentioned that due to the low volumetric energy density, we have a conflict in the necessary space in the available package area in the automotive. And therefore, we develop a flexible multi-cell tank, as you can see here, which might be located in the lower area and consisting of many small tanks which are connected by each other. And these tanks are also manufactured with new technology, for example, based on the Belgian technologies, and especially also based on ecological friendly composites, especially on the basis of thermoplastic resins and matrix systems in combination with renewable carbon fibers, for example. Therefore, we work on design concept. On the large-scale production technologies, we also consider and perform permeation tests, which we can see also on the next slide, in order to bring it to a demonstrator, which tested at bars, at pressures, in the pressures more than 1,200 bar. Damage is a big issue in the development of storage systems, and therefore we develop a broad testing field here at the university, which considers on the one hand the tests of cryogenic conditions, as you can see here on the left-hand side. We do then tests on thermal residual stresses and if there's any damages initiated in the volumes in the tank volume cylinder, and for example by computer tomography on different on a large scale, but also on the lower scale, where we can, for example, detect micro cracks in an area of less than 1 micrometer, and showing also how this crack pattern influences the permeation behavior of the hydrogen, and also to detect and develop new barrier laminates in order to get rid of this permeation or to reduce it. On the other hand, there's also, if we could look at the composite vessels, there a huge test infrastructure has been built up, where we can also, by using artificial intelligence, different crack patterns and adjust and assess these crack patterns with respect to the permeation. We can measure the permeation by a new testant, which mechanical loading together with the permeation tests here, so that we are able to assess the permeation behavior dependent on the damage state, and then we can also assess, for example, these new barrier layers in order to improve the permeation behavior. And this goes so far that we come to new designs and new layups for such pressurized hydrogen cylinders. Yeah, that's it so far. And finally, we are on a very good way on bringing these solutions not only on the street, but especially also into the air. We develop or we work on comprehensive designs for new storage systems, both for automotive and also for the aviation. There is a continuous research so far that we also bring it into the plane and do flight tests here on the whole system. We have a very strong partnership network here in Saxony and also in Brandenburg and Berlin, and which we would like to broaden also with a view to Poland. And that you see very many interfaces there, especially if we think about the small gliders, for example. And we have a very good partner with our UTC network with Rolls-Royce, where we work on different solutions for the storage and propulsion system with regard to the Flight Path 2050 of the European Union to get rid of any emissions in aviation. Yeah, that's it so far from my side. If you are interested in any further cooperation with us, we are open. Feel free to contact us, or also we are open for your questions after these presentations. Thank you very much.
Thank you very much. And we are moving to the next live presentation on this very stage. Filip Grzegorczyk, Vice President of the Management Board at Grupa Azoty, will be joining us now on the stage.
A jest tam ta prezentacja. O. Hi everyone, it's a great pleasure to be here. Thank you very much for the invitation. It's my privilege to represent Grupa Azoty here at this splendid conference in front of such magnificent audience. Ladies and gentlemen, Grupa Azoty is a listed company, and what I'd like to attract your attention to is the fact that basically we are operating in 3 different areas of business. If we could look at the structure of our revenue, it's quite clear that majority of our revenue is extracted from agrofertilizers, and the second pillar of our activity are plastics and chemicals. So as far as we talk about hydrogen, ammonia, this is a very important part of our activity. I would like to say that, well, I have to say that Poland is not the only market we work on. We are very active in Germany and Spain. I would even say in whole Europe. But of course, we have some trade contracts in other parts of the world as well. Of course, Grupa Azoty is the leader in fertilizers industry in Poland. We're number one in Poland. Unfortunately, we're not number one in Europe yet. Well, there's free competition, so Norwegian Yara is at the top, but we are number 2 in the European Union. However we look at this, well, it still is the truth that we have a lot of in common when it comes to hydrogen. Before I start talking about the hydrogen, I'd like to tell you a few words on our new strategy. Several months ago, we had to ask ourselves some important questions. Well, questions were easy. Can we still be like we are, or do we have to change? That was the question. The answer was more difficult. The answer on the question how to do it. But I think now we already know what we have to do to change Grupa Azoty into a green company as far as it's possible. Each strategy starts from mission. We adopted a strategy saying that in harmony with the environment, we manufacture fertilizer, plastics, and chemical products. We improve the well-being of people who live in Europe and actively contribute to building our continent's food security. And here I would like to attract attention to two factors, two elements. First one is in harmony with the environment, in tune with nature, which is for some of you perhaps strange for Grupa Azoty. And the other important element is the element of food security. We all have to be aware of the fact that without fertilizers, we would simply be hungry people, because it's simply impossible to feed Europeans without fertilizers. As a problem of utmost importance now when we face Russia's aggression in Ukraine, we see very clearly what can happen as far as food shortage appears. So we have like the most important, I would say, the most important factors, or two most important element showing our future way, which is harmony with the environment and still our continent's food securities. Ladies and gentlemen, in this strategy we adopted the concept of Green Azoty 2030. It's a concept concerning huge change, huge transformation in energy, in chemical process, and in producing ammonia and fertilizers. What we want to achieve is a huge reduction of CO2 emission as soon as possible, and on this graph you can see how what are our achievements and what we are planning to do next. So first of all, to be more green, we have to make a diversification of energy sources. Of course, we have a great plan to build our own green energy sources, at least 300 megawatts till 2030, and I hope in a few weeks we will have pleasure to announce some concrete projects in the field. But we also have to emphasize the importance of nuclear technologies. I know that perhaps you're not all fans of nuclear technology, but unfortunately our view from the industry's perspective is that it's impossible. It's impossible to conduct regular activity when green energy sources exclusively are the base. It's simply impossible unless we have energy magazines on industrial scale. We don't have it. It's not available right now according to the best knowledge. That's why nuclear technology will be very needed by industry. In my personal opinion, I think that's a matter of regulation, and I think that nuclear technology should be qualified as green one, or at least zero emission. At least zero emission. Of course, I'm not talking about huge power stations. I'm talking about medium, small reactors, which are the best solution for huge industry. I'm afraid without this, no real change will be possible. Ladies and gentlemen, what we have to achieve next, well, it's in a connection with the previous slides, decarbonisation of energy. And I'd like to show you these two graphs. That's how it looks like right now. That's what we want to achieve in 2030. The biggest numbers is the reduction of 34% in the CO2 emissions from in-house energy generation, the reduction of 51% in CO2 emission from purchased electricity generation, and finally 65% of reduction in coal consumption at Grupa Azoty. That's what we want to achieve until 2030. Well, this plan is quite ambitious, but I hope we can do it. I'm sure we can do it, but we'll see. Of course, the next perspective, it's perspective of 2050, right? But probably it won't be our problem. So, of course, we have some plans which are not identified very clearly. They're not identified by numbers, that's for sure. But of course, we have to bear in mind that this 2050 perspective of zero emission economy, there still must be somewhere in as a part or important element of our mindset. And of course, coming back to the crucial point, the most important point of this conference, which is hydrogen production. Ladies and gentlemen, Grupa Azoty is #1 producer of hydrogen in Poland. Unfortunately, we are also the biggest natural gas consumer in Poland. And it's a simple fact arising from the whole technical procedures. I mean, we produce fertilizers. It's based on natural gas, and of course the hydrogen is needed here. Well, our problem, and it must be admitted, in the context of European Green Deal, is that the hydrogen we produce is not green. That's the problem, and we're quite aware of the fact. But we always think on what we can do about that, what we can do, how we can change, how we can get the green hydrogen. But what I have to emphasize, on the industrial scale. And we have some good examples. We have many R&D projects towards green. When we focus on hydrogen, we're working on adapting the ammonia unit to receive blue hydrogen streams from PDH unit. We are developing an alternative fuels laboratory in Kędzierzyn-Koźle. This laboratory is for testing of hydrogen for automotive applications. We have huge project in our site of Puławy, where we have a pilot project and we want to design a commercial plant from the very beginning, a commercial hydrogen and ammonia plant using 100% renewable energy. These are R&D projects. We are dealing right now, but our general view on the green hydrogen is not too optimistic, to say the truth. This statement arises from several facts. In our opinion, we can do a lot of small projects. We can demonstrate a lot of technologies, etc., etc. The question is, can we show anything for an industrial scale? The main problem we have right now is that renewable energy sources are not stable and are expensive. They're not cheaper than conventional sources of energy. Our analysis show very clearly that Europe is not that part of the world where green hydrogen is profitable. Well, it's just too expensive, and there are no good, I would say, natural conditions for producing that. It's not here. Where is it? Of course, it's in place of the world where you have sun during the day and strong winds during night. So it's more like Africa, I mean, the Central Africa, Asia. That's much better. These are much better territories where you can do it. So the problem is that, and that's our, as industries, as huge industries' opinion, is that actually there are two choices. Or you or some financial and regulatory frameworks will be adopted, frameworks allowing business to go this way, or you just say, we don't want to produce green hydrogen in Europe. We don't need green production of green ammonia in Europe. We can buy it. But it must be, well, it must be a choice. We cannot pretend that it is not an option. Unfortunately, when reading draft legislations on European Green Deal, we don't find any kind of good solutions for big industry in terms of financial and regulatory frameworks. But at least the European Commission should say, okay, we don't want green ammonia, we don't want green hydrogen produced in Europe. We want just to import it. But let's
I'm sorry, we have to come to the conclusion because we have run out of time.
I've just come to the conclusion. So thank you very much. It was a pleasure once again.
Thank you very much. And our next speaker is waiting to join us to present the Lombardy experience. Sergio Torriani, the Managing Director at Simplify SB and Delegate for IL-E2C cluster, is joining us now on the screen. Good afternoon.
Yes, good afternoon.
Here you see, the stage is yours.
Thank you very much. So I would like to share my screen and presentation. I hope you can see it. Can you see it? I shared, but I don't see anything. So again. I don't see my screen on, can you see my screen?
Yes, we can see your presentation shared with us.
Perfect. Okay. So I'm Sergio Torriani, as you presented us. So good afternoon, everybody. I am here with two roles. Let's say my work is in Simplify. It's a startup mainly dedicated to hydrogen solution. And I'm here to talk about what Simplify did and is doing in Lombardy. And secondly, most importantly, I am here presenting what Heli2C is doing in Lombardy in terms of supporting the hydrogen economy, and which are the initiatives as Lombardy Energy Cluster that we are driving, and we are willing even to propose internally of the Vanguard Initiative too. So a short introduction about simplify what we do. Indeed, we are a system integrator that is able to integrate the solution and experience in the world of energy and integrating it for solution in hydrogen. So saying in short, we do a lot of different things. We do consulting, we do piloting, we develop a solution. We are a lot more focused on, let's say, industrial and industrial scale application than not research or university. So we have, let's say, a dedicated level of really doing engineering, procurement, installation activities related only to hydrogen space. So I know today we had already a lot of different applications. This is a slide that I'm used to use for disseminating where hydrogen is. And hydrogen can be everywhere, even if it is the most common element in nature, even if it is not a natural element as it is, but for the industrial application and for the decarbonisation application, we are going to need in several kind of application and several kind of decarbonisation. Now we had the group Azoty talking about the decarbonizing industrial energy use, and specifically for which are the application around ammonia and fertilizer, but indeed there are so many applications. So as a Simplify, we are already working in doing a lot of different applications in Italy, starting from a project of 8 megawatt and a small application of a few hundred kilowatt that are industrial applications. Some of them are, let's say, even without subsidies. And we are supporting renewable development on make it real, this work. And we are working even on bigger initiatives that are, let's say, in this case, a little bit more subsidies related, but there are really happening in Italy. So we are seeing things happening in Lombardia. And even small application in the industry where small company need hydrogen, today, a best solution for them is make it by renewable sources on their roof. And so this is something that we are doing today. So it's not so complex, it's already a reality, a renewable hydrogen in Lombardia. And just to go fast, another application where we are working on is a lot of renewable campfields or building sites require to have local energy, remote energy connection that has to be green. And today this is not possible. Usually you do with the diesel engines. And we have a solution to deliver them green hydrogen and by fuel cell delivering energy to their campsite or to their building sites. So again, it's not something that is going to happen. It's something that is happening today in industry, not so only in research. And again, a few words about Lombardy Energy Clean Tech Cluster. I have been impressed by the university presenting their capabilities. In Lombardia, we have 11 universities that all of them are participating in our cluster. And each of them has a today initiative around hydrogen. So they do research, they have labs, they are doing activities, and it is very important for us in the cluster create this contamination together with institutions, with industrial association, bank. That's something that makes, let's say, the difference sometimes, and a lot of industries. We are one of these. and but the cluster is including a very big corporation in Lombardy and small, medium enterprises as we are. So it's quite interesting that in 2020, Lombardy Energy Cluster, and with this, the Lombardy region decided to work on what they are used to do. So energy and clean tech open innovation, working on energy and regional funded project, and a special project dedicated to developing technology in the clean tech energy industries. But one of the main pillar where this is going to be the results of the final results of what we are going to do as Lombardy Energy Cluster is the hydrogen development. So today, we really believe as a cluster that this is one of the main pillars that is helping us to developing a smart energy system, sustainable manufacturing, green building and water energy and clean air and circular economy. So around that, there are a lot of initiatives that are working around the Lombardy. And what we have here is the specific experience that we already started and we would like to share with you. So the collaboration and contamination between the university institution and the industry has given an easy today mapping a tool helping SMEs everywhere indeed in the world. That unfortunately today is just in Italian, but to look which are the university that are already working on hydrogen and which kind of technology they are looking at. So together with the Industrial Association of Lombardy, Assolombarda, and together with the Italian branch of Hydrogen Europe, that is H2IT, we developed this database that is already available online, and obviously is going to the other screen. So I will try to share this one in case, but this tool is quite powerful to help you to just coming with the with sharing it. I hope you are seeing it. Biomass and so on and so forth. So indeed, it's just a way to help the industry to get in contact with research center and testing center and testing labs in order to go in detail and see what it is possible to do in Lombardia by now, but this is a tool that we want to share within the different European region in order to let's say, helping the ecosystem of research and the ecosystem of the testing facilities to be more close to the industry and helping the growth of new products in the hydrogen space. So that's in really short what we can present. I just have another small slide that is presenting one of the initiatives that in Italy we are now developing, specifically in Lombardia. So we are now waiting to have final decision by the government on something around 30 Hydrogen Valley in Italy, and we expect that 4 of them, 3-4 of them will be in Lombardia. On the other one, I don't want to share anything because it's still not public. There will be official tender that has still to be done, but this is an initiative that is already in place, so it's already happening, even without the funds that I'm telling you about. And this is a very important line because we are really talking about more than 100 kilometers of railways that are from Brescia to Edolo, that is in the valley, that are on the mountain, let's say, I would say behind Milano. And what we have here is an interesting collaboration between very big corporation like A2A, that is the municipality of Milano and Brescia, Enel and Snam, supporting and delivering hydrogen for the transportation of the train on this line. This is a project that has already in order 8 trains, and it's supported by 3 different electrolyzer lines, 3 different refueling points, as steam methane reformer, and is already enabling the public network to become hydrogen fueled. So this is one of the main activities we are expecting to improve the use of hydrogen in Lombardia. So that's it. Thank you for the time. I hope I've been not too long.
Presentation. Disturb. Future, and Anna Maria Borsznik-Bracic, head of the Energy Division GP Systemi, is with us to present the subject. Please join me on the stage.
Thank you. Could I have my presentation, please? Oh, thank you. Okay, so I would first like to thank the organizers for inviting me here. And I'm here as a representative of Slovenia, so we are co-leader of this proposed hydrogen pilot. And otherwise, I'm the head of energy department in GP Systemi, and we are so far been very active in development and execution of projects in combined heat and power plant fueled by waste. Okay, so Slovenia is a rather small country. It's like 600 kilometers from here in the direction of southeast, lying at the Mediterranean. But nevertheless, even though it's only 600 kilometers, it has taken me 20 hours yesterday by plane, since the first plane in the row was delayed. As you can see, there are many forests in Slovenia. So Slovenia is the 4th country in Europe, comparing the shares of the forest in the country. The first is Sweden with 75%. So Slovenia is 60. Does anybody have the feeling how much is in average European Union? How many, well, what share of forests are in EU? It's like this, like 20%, 30, 40, 50? 40, yes, it's 40. Because some Scandinavian countries, but also central part of Europe, there are many forests. Why are forests important in this hydrogen story? So in the forest, there is a lot of waste materials. So wood, which can not be used for anything else but like combustion or production of hydrogen. And there is gasification process in development, not yet commercialized, but very close. And this is very suitable for production of hydrogen, of green hydrogen. Okay, so Slovenia is here, you can see. Here is the map of sun. So in Slovenia, there are many photovoltaic power plants being built, and 1 kilowatt hour of photovoltaics in Slovenia can produce about 1,100 kilowatt hours in 1 year. So why is this important? Of course, if you go more to the south, like colleague before said, to the Africa, it's much better. But also in this region, so in Slovenia and also in southeast region, there are huge plants of photovoltaics. And of course, this is connected with hydrogen because there is not yet huge storage available for the surplus energy. And so as there are huge plants for the photovoltaics, this has to be somehow accompanied with some systems which will stabilize the electrical grid. Okay, and so as we said, in this part, southeast of Europe, there are many plants for the photovoltaics, and these red and blue lines are the existing pipelines. Oops. I'm sorry. Obviously, we don't go very well together with this presentation. So the blue lines are the natural gas pipelines. The orange ones are the planned backbones for the hydrogen. But for sure, the most easiest way is to install new hydrogen pipelines in the same route as now the natural gas pipelines are. Okay, so what are current activities concerning hydrogen in Slovenia? So as green hydrogen, I'm talking about green hydrogen. Of course, there is a lot of gray hydrogen being produced for the chemical industry and for the process industry. And now the idea is to replace this gray hydrogen with the green one produced from the surplus from electrical energy from the photovoltaics. So the projects which are here are mostly funded by EU or some local funds because, as I said, and we all know, it's not yet commercially very attractive for private investors. So there are new technologies for production of hydrogen going on. There is green hydrogen for glassworks. It's a lot of interest. I will show you an example a little bit later. And then there are some materials for storage of hydrogen developed. And there are some projects concerning the promotion of coupling of electrical and gas grids going on just with the purpose to convert the surplus electrical energy into some other energy carrier, which could be green hydrogen, biogas, or something then later developed from this green hydrogen. Here is one demo case or pilot case in Slovenia. So this is for the glass factory. This is a premium glass factory, so the process is very sophisticated and can be really has to be optimized in order to produce such a good quality of glass. So the idea is now to reduce the carbon footprint, is to use, instead of natural gas, renewable sources. And in this concrete project, so a small, well, rather or not small, 180 kilowatt peak photovoltaic power plant was installed, equipped with alkaline electrolyzer, hydrogen storage tank, and pilot glass oven. So just to test how this will behave. And in addition to this, it's oxy-combustion, so we don't have nitrogen, and we don't have nitrogen oxides, which are also problematic for the environment. So what is coming next? So these are the projects which are now running. there is huge interest in project development. So, well, in the terms of this conference, or maybe it could be also called hydrogen valleys. Why? So there are really plans in the area for many large photovoltaic power plants, like 50, 100, or even 2 or more 100 megawatt peaks. And as there is not such a huge consumption of electrical energy in the Balkan countries, for example, in Slovenia, we have about 2 gigawatts in average. Croatia has double, because approximately they are twice as large as we are. These large power plants will definitely have a large impact on the stability of the electrical grid. So there should be some system which will help to stabilize. And the idea is now to build, well, prepare many projects in this area. So that means select the field together, buy the land, get all the optimal technical solution, and get all permits valid. So the same as we do now for the power plants. And as this is a couple of years long process, we believe that when all these permissions will be valid, also the technology for the production of the hydrogen will be well, in the phase of commercialization, so that the circle will be somehow closed. Okay. This is actually what I wanted to share with you today. So I think that hydrogen has a very bright future, and that, well, connecting together different regions, what is the idea of Vanguard Initiative, could really help making a large step forward in the next years.
Thank you very much for this aspect, and we are moving back to our online presenters for the next perspective, the Scottish one. Irina Bonavino, hydrogen specialist at Scottish Enterprises Low Carbon Transition, and Steve Taylor, trade specialist, energy and low carbon transition from Berlin Scottish Development International, are joining us live. Good afternoon.
Hearing anyone.
Hello, I hear some voice, so I suspect we will still have the connection. Good afternoon.
I can't hear Irina's voice.
Mini, do we have Irina on the line? This is my question to our tech staff. No, we don't have Irina. So
Irina was online and she has the presentation.
Evidently, she dropped off the call.
Which, I'm probably excuse me because I haven't practiced these, but I've heard her go through them. So first of all, hydrogen is seen as a great opportunity for Scotland. I think the first thing to mention is that Scotland became the first country to state that there was a climate emergency and set the very hardest net zero targets. We were the first to set a net zero target by 2045. We had to think how we were going to do this. Now, we in Scotland have a number of strengths when it comes to hydrogen. Those of you who've been to Scotland will know we're a very windy and very wet weather country. Sometimes we don't like that, but it does have some great advantages, especially when we start talking about renewable energy. Now, 25% of Europe's offshore wind resource is off the coast of Scotland. And following the recent ScotWind round, we are expecting to have 25 gigawatts of offshore wind produced in the next 6 to 7 years. The process is starting now. We have political backing for renewable energy. We have innovative hydrogen projects that are starting, and we're in a good position where we are producing or are about to produce green hydrogen for export to the European market. We're in a good geographical location and in a good position to export. Within Scotland, we've realized that there are a number of disparate but very positive projects, and some of these, for example, the working on hydrogen in transport. And in the Orkney Islands to the very north of Scotland, the European Marine Energy Centre, which set up the first project in the world that generated green hydrogen from tidal power. We've now brought all these various initiatives together under the name of SHINE, which is the Scottish Innovation and Academic and Technology Network. I've just got a message that Irina is back, but I'm wondering if I don't know, Irina, whether you want to come in on the next slide or whether that's too confusing or whether I just carry on. Yes, Irina will talk to the next slide and then it'll be back to me for my slides anyway. Irina, over to you.
Yes, thank you, Steve. And my apologies for my internet crashing at the very worst possible time. I enjoyed the previous presentations. Yes, so with regards to what Steve was talking about with the SHINE network, we hope that this will provide a focal point for innovation networks to collaborate with Scotland. It encompasses a great deal of universities, innovation park, technology centres. And so in line with the smart specialization concept used in Vanguard, we hope that they will be able to make the most of this along with the platforms that we're producing with the hydrogen pilot. In terms of the collaboration that we hope to exemplify through the Vanguard initiative, Scotland will co-lead a couple of activities, including the regional portfolios workstream along with Wales. And the objective of the workstream is to apply the Vanguard methodology of learning from each other, building up our hydrogen economies together. So the idea for this moment is that every region will be able to submit one-page documents highlighting their most successful hydrogen experiences. They will be built up into a database of knowledge so that we can understand each other's specific portfolio of hydrogen and we can replicate good practice. For example, some of the projects that Scotland could share, 105 projects seen there. This will produce hydrogen from offshore wind and introduce 100% hydrogen gas into 300 homes next year. So this will be an important test bed to provide evidence of how to safely introduce heat into a residential market, and it will inform the UK government's policies and regulations on heating using hydrogen. Another successful example is in Aberdeen, where hydrogen began to be used several years ago. There was a first fleet of hydrogen double-decker buses in Europe introduced in 2020, and now the fleet has grown to 25 buses, several vans, a road sweeper, and even some waste collection vehicles powered by hydrogen. And so this source of local demand has allowed the City Council to scale up hydrogen production within this urban setting. The plan is for the Aberdeen Hydrogen Hub to create a solar farm in the city. And the surrounding offshore wind farms are also starting to announce some projects where they want to produce hydrogen based offshore and then pipe it to Aberdeen. So Aberdeen's experience could well resonate with other European regions that are looking to do a fair energy transition, and we hope that we can share this through Vanguard. Now I'll pass on back to Steve.
Thank you, Irina. I think we've seen there that in Scotland there is enthusiasm, innovation, and a lot of activity in the field of hydrogen. But what I want to do now is specialise and focus in on one industry. And what better product than Scotland's most famous product, Scotch whisky. Now, in Scotland, we produce 400 million litres of whisky per year. It's quite energy intensive. The carbon footprint of that is about 2.6% of the whole of the Scottish carbon emissions. And as long ago as 2009, well ahead of their time, the Scotch Whisky Association decided to set about decarbonising the industry as a whole. Now, since then, the carbon emissions associated with Scotch whisky have been reduced by 53%, which is a good figure. But there's still a long way to go. Now, one of the distilleries I want to focus on today is Bruichladdich from the island of Islay that have set up what's known as the High Laddie project. Now, they've set out to decarbonise the whole distillation process by 2025. They are currently partnering with a Scottish company, a Scottish energy partner, Protium, who will use for the first time in this industry a dynamic combustion chamber hydrogen boiler to heat the stills. Some of you may have tasted the Bruichladdich Scotch whisky or the very famous Botanist gin. Now, they started off by doing a feasibility study looking at different technologies and secured £2.65 million of funding to install the boiler, which was seen as the most likely successful operation going forwards. Now, in addition to the heating process, Bruichladdich are looking at decarbonising the transport and the actual growing of grain and the products, the ingredients that form whisky. One of the things they want to do with this project is not as their own distillery, but demonstrate how this technology can be used elsewhere. It's a 150-year-old distillery. It's very difficult to put state-of-the-art, but they've demonstrated how it can be done. And this is something that other distilleries in Scotland can learn from. But in addition, they want to use the demonstration of how hydrogen can be successful in the distillation process for other industrial buildings and public buildings on the island of Islay, such as schools, public buildings, and hospitals. But going back to the distilleries, I've put in a couple of pictures of two well-known Scotch whiskies that some of you may have tried in the past. Two of these are worth mentioning. The first, Highland Park from the island of Orkney, is working with the European Marine Energy Centre, which you've already heard about in Orkney, and they will use green hydrogen to decarbonise their distillation process. It's starting now, it's just getting underway, we're right up to the minute. It's not operational yet, but it's getting there very, very quickly. And then perhaps slightly further in the future, Glenmorangie is working with the Port of Cromarty Firth on a really ambitious North of Scotland hydrogen programme, which will take wind from the ScotWind offshore wind projects and use the wind power to generate a 35 megawatt electrolyser to decarbonise not just Glenmorangie, but other distilleries nearby. Why are we doing this in Scotland? One of the things we do going forwards, we look backwards, and we talk today about an energy crisis. We also talked about an energy crisis in the early 1970s. And the solution then was that in the mid 1970s, we found North Sea oil. But the industry experts said, you've got oil off the coast of Scotland, but you'll never get it out. It's too difficult, it's too deep. The wind is too strong. The waves are too big. You won't get it out. But you know, Scottish innovation, Scottish engineering excellence, Scottish determination, perhaps, we managed to get it out. And 50 years, North Sea oil and gas has been one of the mainstays of the Scottish economy. But now, as Scotland set zero carbon targets, we're moving away. We're transitioning away from oil and gas, moving to renewable energy in general. But we're doing what we call a just transition. We're not going to leave the workforce behind, which has happened so often in the past. We are working with the workers involved in North Sea oil. We are appreciating not just the innovation and the engineering excellence, but the way the whole of North Sea oil and gas in this really extremely difficult environment has become an innovation ecosystem and a hotbed of new technologies, excellence in engineering. And we're doing our best now to work with companies, using the public sector to help train staff, work with the companies to develop new opportunities in the field of renewable energy. Hydrogen is becoming one of the most important aspects of what we're trying to do with this just transition. And we're using it to look at distilleries across Scotland, work with as many of the distilleries as we can, get that reduction in carbon footprint down to an even greater reduction, and then think, how can we use this to work with other organizations, other distilleries in Europe? And I found it fascinating when I looked into how many distilleries there are in Germany. And according to the German Distilleries Association, there are 15,000. Now imagine if we could decarbonize just half of those with hydrogen heating, what a difference that would make. And that, I think, is the way I'd like to finish this off. We are working very hard with our most famous product to decarbonize, and we want to share that experience and help other areas of Europe to do the same thing and decarbonize their own distilleries and other industrial processes. Thank you very much.
Thank you very much for this presentation. Next Generation Hydrogen High Storage Solution for FCEV. The Director of Global Business Development, HRC Germany, Erich Freis, will be our next presenter. And I hope we are already connected. Good afternoon.
Good afternoon. I hope you can hear me loud and clear and you see my presentation.
We can hear you, and I hope that we will see your presentation just in a second. So the stage is yours.
Okay. So first of all, thank you very much for giving me the opportunity to introduce the HRC group and our partners. And today I will focus on the holistic approach for the future hydrogen storage systems. Before I go in this topic, let me allow you to give you a little background about our company. I mean, we have been established in the year 2014. We've been established in China. We started with 30 people, and over the last years we growed quite a lot, and we are up to date. We are 900 people. In the market, and this is also important for the next slides about hydrogen, when we started talking about composite and being a manufacturer from composite components, we also realized that we need to do a bit more than just manufacturing parts. We also need to put our thinking into the entire process engineering, and also we need to understand the composite engineering and also the material approach in order to give our customers the best possible solution wherever they are active. So basically, our group, we are working globally. Our main manufacturing setups are in China. We have about 50,000 square meters over there for doing composite components for the automotive industry, as well as for the aviation industry. And also what you see here, we have established a tech center called ACTC, which is a cooperation with the Fraunhofer ICT, where we have an 8,000 square meter development platform where we can work with the latest materials and also design and engineer products according to our clients' demands. We are active in different markets. Automotive, transportation, building infrastructure, and aerospace. And that was also important for us to understand what is going on in the hydrogen market, as we are dealing on a one-to-one regular base with all the major OEMs. Here you see an example. We are building the entire car, the composite components, for example, for the Polestar 1, where this car is consisting out of 62 components made in composite. And we understood a lot the requirements of an OEM, and we also understood a lot what is the need in regards to quality and at-line delivery if you deal with OEMs. And this is also a good learning for the future hydrogen approach. But as I heard also before, I mean, hydrogen is not a topic we have to rely on transportation markets such as truck, buses, and maybe also the automotive. We also see a lot of movement in the aircraft sector, or as an example here in the urban air mobility sector, where we did some prototypes for the company Xpeng. And we also have a lot more discussions right now in regards to hydrogen. So hydrogen for us is, I would say, it's one of the hottest topic we are analyzing right now. And here you see, for example, the numbers of the 5 years plan in China. So FCEVs in China by 2035, there should be 1 million cars or trucks or buses on the road. And if you consider how many storage vessels they need, we are talking about a yearly volume of 3 million to 8 million pressure vessels only on the Chinese market. And therefore we decided we need to make a very strong approach in this market, and we need to build up a very strong team to serve that market. But before we did this, we actually analyzed the future hydrogen economy. So where do we bring value as a company to our clients? So where can we bring our knowledge and our expertise to the market? And we heard about green hydrogen, and there's a lot of approaches in the solar cell market and also in the wind energy market, but that's not the markets we are typically serving. So basically by analyzing the market, we determined for us that we want to be more active in the storage systems for stationary H2 storage, for public transportations, for railways and transport vehicles. To do this, basically, we analyzed our capabilities and we said, okay, we need to have strong partners to really approach our people with the best possible solution. So therefore, we are working with institutes like Fraunhofer, with the ITA and with the RWTH Aachen University together. But we also already start discussions with the Tongji University in Shanghai, which are doing something. And we would be pleased to also get more involved in Poland, for example, to share our expertise there. And we signed recently a cooperation agreement with the company Voss and the company Hypetech. And I will share a little bit more details about this. So the company Voss for us was a perfect partner because this company is well known, first of all, in the market. They supply to the transport market many components such as valves and modules for SCR systems and also modules for the temperature management. So they fit perfectly. If we had no overlaps, they are focused on valves, pipings, and controlling those systems. We are focused on composite components. And luckily, the company Voss was acquiring the Austrian-based company Hypetech, which is an accredited hydrogen test laboratory. So everything we can develop, we can test right away there and make sure that it meets all the certifications. So our focus on development is to develop a special type 4 pressure vessel where we take into consideration all the knowledge of our partners in the market, especially when it comes to the valve technology. We want to have an integrated valve in the pressure vessel to minimize the complexity, but also to offer a very cost-effective solution to the market. So basically, you see here an example. What we want to do is, we want what you see on the left side of the picture. We want to minimize all the parts you need for controlling, for the valves, inlets, outlets, for the OTS, because we want to have an integrated solution, what you see more like on the right-hand image, so that we need, first of all, less space. We have less risk of leakage. And we also can have an easy assembly. And on the right picture, you see like a common rail system where we want to integrate more containers into one complete module, because we want to supply by the end of the day the whole module to store hydrogen in those pressure vessels. And just as an example, I mean, we have to break it down into very little exercises because we are talking here about the safety related part. So only if we talk about the BOSS system, which is up here, we need to take into consideration different tasks. We need to understand the manufacturing approach. How can we make it faster? How can we minimize the usage of an expensive material such as carbon fiber? And we need to make, of course, the assembly fast and reliable, but also in regards to functionality, we need to take into consideration that you maybe need access hole for inspections and cleaning. And of course, you need to have the possibility to mount the winding mandrel on top of it. So there are many exercises we are doing right now, and we will be ready with our own Type 4 certified container for the Chinese market as well as for the European market within the next months. And to do this, we constantly massively invest into the latest state of equipment. Here you see a filament winding machine we just recently installed in our facility, where we can make different sizes, different lengths, different diameters. We also can do material combination, carbon fiber and glass fiber. And basically, we would love to share that experience and our portfolio with partners in Poland to really work closely together and to develop everything according to the market needs. But also, what we heard before, sustainability is also an important topic for our company. So therefore, we take already into the current design and development work we are doing. We are taking care about the CO2 footprint of the project, of the product. We make an economic calculation. We select the right material, and we are also working with partners right now on recycling, because you have to take into consideration, if you make a pressure vessel, the size you have seen on the picture, which can store approx 60 liters, you wind almost 20 to 30 kilograms of carbon fibers around such a vessel. And it would be really a shame to waste such a material after you're not allowed to put this vessel in a car or in any transport vehicle. So we are working constantly on a system to reuse it, to bring it back, maybe in secondary processes. So basically what I wanted to deliver today in this speech is, we are working on a very specific topic, which is, I think, a real need in the market. Also, we all have to discuss how we can optimize the production, and we need to, if we took a look into the potential which is given by the Poland market, for example, we need to also think about to set up productions over there, to also really take the logistic into consideration. And we started our journey in the year 2019, and as usually in composite and in other segments, we seek for good partners to offer the best solution for our clients. We are working on the first prototypes, we validate them and we certify them and bring them into the market. And we hope that due to this event today, we find some partners to work together in the future. We have two dedicated people in our team, Dr. Timo Huber, which is taking care about our development at the ACTC, and Dr. Hans Christian Früh, which is the head of business development at the company Voss. And those two are really our power team to support our customers for their future needs. And we really hope this event can help, that we all come a little bit closer together and we design and work on the future together. So thank you very much. And if there are any questions, please to get back to you.
Thank you very much for being with us today. And now we are moving to the next presenter. Raimund Grothaus, CEO East for Decarbon Technology, will present to us the VUCA world, climate change and the new megatrend, globalization. How does this affect the European collaboration on CFRP hydrogen pressure vessels? Good afternoon. We're waiting for the connection, and shortly we should have our speaker with us.
Hello, and good afternoon.
Good afternoon. We can hear you. Surely in a moment we will also be able to see you. Yes, we can see you. So please go ahead.
Yes. So I'm quite happy to be in the position to share our presentation today, and especially after we did have a previous presentation on carbon fiber pressure vessels. I'm happy to continue that discussion. Please inform me if you can see my presentation.
Just in a moment, we'll see it, hear it as well. Yes, we can see your presentation, so you may go ahead.
Okay, so what is the status where we are right now? We are right now in a VUCA world, in a VUCA environment. And what is the topic we need to discuss about European cooperation on CFRP hydrogen pressure vessels? So what happened over the last couple of years? We did have the crisis of the euro in Greece. We did have the financial market crisis, the refugee crisis. Most recently, we had the corona crisis. We still have the climate crisis. And unfortunately, right now, we have the new Putin-Ukrainian crisis. And we already see on the clouds inflation crisis coming close. But on the other side, we have the good opportunities of the Internet of Things. We did find out new work topics, homework topics, and we have the big topic of artificial intelligence. And maybe coming out of all this crisis, we come back from globalization. We might come back to a more local business and environment with localization. So we all together, we are fully sure that oil and gas needs to be substituted. We have discussed that over the last presentations. And where are we? We are in a new work environment. We have requirements for sustainability. And especially Putin puts maybe a so-called change of the time to all of us. So we might look more critical on a supply chain strategy to democratic systems, which are also maybe more closely related to Europe. So this might be a sustainable growth opportunity for Europe. If we look to hydrogen, we have maybe three main topics: generation, transport, and especially storage. For storage, we require cost-competitive solutions. And for this kind of cost-competitive solutions, composite pressure vessels are one very nice storage solution. If we talk about composite pressure vessels, we need to have sustainable but also disruptive composite pressure vessel innovations available to be competitive in the worldwide competition. So if we look to this kind of Vanguard activity, collaboration between research institutes, innovative small and medium-sized enterprises, but also large-scale industries, this offers gigantic hydrogen market opportunities. So our company is free. We are a small and medium-sized company, and we work along the whole technology development. So we have done initial concept ideas with technology readiness level 1, went over to serial production, and right now we are a sole supplier of filament wound aero engine nose cones, as you can see here on the picture. These are driving all Airbus A350, for example. So what is the key competence of E3D? Key competence of E3D is that we improve the competitiveness of our European customers by up to 60% cost reduction using dry filament winding together with a resin infusion technology. This gives more or less 4 reductions: reduction of process cost, reduction of raw material cost, reduction of permeability, and reduction of energy consumption. Especially for the hydrogen vessel business, the reduction of permeability is extremely attractive. So this kind of permeability reduction is responsible for lower permeability hydrogen losses, which makes the system more efficient. So this is not only theory, this is innovation which we have done and proven in the past. So we are a technology company, but we do have multiple references in a lot of flying projects, also in the automotive industry, railmotive industry, and most recently also in marine electromobility applications, where we're extremely pleased about. So what is the interesting topic? The interesting topic is that in Europe, we already have a quite good landscape with regard to carbon fiber manufacturing. Nevertheless, in the US, they have the strongest footprint on carbon fiber manufacturing. There's another strong footprint in Asia, but also here in Europe, we have a quite competitive, good situation. This carbon fiber manufacturing business is so important because the cost breakdown for hydrogen composite pressure vessels gives more than 60% of the costs they are related to carbon fibers. So competitiveness is driven by understanding the carbon fiber usage. So what do we want to need? What do we want to do? We want to innovate the carbon fiber process. So we want to initiate disruptive technologies for hydrogen storage, going to material, design and process innovation for composite pressure vessels. But also we need to understand the global competitive situation. For all that, especially nowadays, we need to understand data. We need to understand the data for costing, but also for the carbon footprint. This kind of data understanding has been done, at least for many years. So we have done a lot of statistics. They are available with historical data of more than 10 years, where we are able to assess costs, to distinguish between material costs and processing costs. That has been established in automotive, but mainly in aerospace applications. So all that feeds into a cost modeling program. So we need to have a good database to understand different materials, different machine setups, different manufacturing processes, dry winding, wet winding, tape winding, all that needs to be understood. What is the impact of local environmental, different taxes, CO2 fees? And we are working on an artificial-based composite pressure vessel data assessment to find out the most competitive solution. Nevertheless, also the standard engineering work has to be done. So we do have an agile composite pressure vessel development and qualification procedure in-house, which is more or less standard, but going on a detailed analysis level. We do also do prototyping and the production of small up to medium volumes for filament wound structures. We do have free filament winding capabilities in-house. And also, it's quite important that for large volume topics, we work as an independent consultancy for these customers. If you go to our internal target to be carbon neutral in 2030, we have developed our 2022 to 2025 roadmap. So the challenge is mainly to understand costing, especially in this kind of VUCA world. Where do we get the carbon fiber? What is the impact of carbon fiber costs and all that? So coming out of that, we work on disruptive solutions. We work on type 5 pressure vessels to have more competitive advantages for that. And coming out of that, we want to offer our customers a more competitive and cost-optimized design. So a lot of internal projects funded by the state of Saxony, by the German ministry, but also by the European community, we are working on that. So all together, if we go to hydrogen as a new fuel of growth, which is the motto of this conference today, we summarize following key elements. We need to understand in all activities 3 columns of sustainability: ecology, economy, but also social life. Especially the social life is one of the 3 elements for sustainable developments. We need to be carbon neutral, we need to be cost efficient and competitive, but also we want to have supply chains with a high value added work stream in European or democratic systems. So this is this kind of new element which comes out of this Putin crisis. We have a new trend of so-called localization coming back to local added work streams. So in that context, this conference right now is a perfect platform to exchange collaboration ideas between politics, research, industry, small and large enterprises, but also NGOs to all come together with sustainable decisions. And to our understanding, it's very important in this kind of VUCA world to have also artificial intelligence-based digital decisions, to have sustainable decisions where we all come to the same level of final conclusion, because these decisions are data-driven. So ISFOD, as one partner, accelerates also the European hydrogen growth by data-driven process innovation. We have done that in the past. We supply vessels for aerospace, so we are quite happy to support all the partners which are presenting here today. And please do not hesitate to give me an email contact, and thank you very much for your attention.
Thank you very much for your presentation. And now we are waiting for Professor Holger Seidlitz, BTU Cottbus Seftenberg, to present to us from monomer to component, sustainable lightweight technologies for the energy. Good afternoon, Professor.
Good afternoon, Vitam.
Please kindly take over the stage. We can hear you clearly.
So, Mr. Grothos, you have to stop your presentation. So otherwise I can't start mine. Okay, thank you. No, szanowni państwo, witam na moim wykładzie. Jestem G. ostatni i mam nadzieję, że nadal masz energię. Nazywam się Holger Seidlitz, a teraz dalej w języku angielskim. So it is a big pleasure for me to present my slides today at this conference. The topic of my presentation is from monomers to components, sustainable lightweight technologies for the energy transition. So I'm at the Brandenburg University as well as the Fraunhofer Institute of Applied Polymer Research. And I'm responsible there for the research division, polymeric materials and composites. And I'm sorry for the problems with the slides now. There is a flow inside. So what does it mean? So we are involved in a lot of lightweight projects that deal with composites. And we do have the competencies, I will stop it, sorry. We do have the competencies in the materials as well as in the cases of design and processing technologies. So, and this is a big advantage, I think, because we always say we offer lightweight solutions from a single source. So, and what we can do is we are able to modify, to develop polymers. We can scale up them. We can produce our own semi-finished components, prepregs, for example, slit tapes or tow pregs, basic technology for the storage of hydrogen, and we are able to do the simulation jobs, the design jobs. We are able to produce our own vessels, and we are also able to test them there. And regarding the tests, we are working close together with the BAM, Bundesanstalt für Materialprüfung in Berlin. So, and this is a big advantage because of that we have a strong network. So, and network, what does it mean? We are also involved in the hydrogen networks, H2 in Saxony, as well as Durchatmen in Brandenburg, and we are well organized in the Composites United. So since 6 months, I'm also a member of the Presidium in this network. So, and we are also organized in the Lausitz Science Park, because what you can see here is that we are located near of Berlin, but also in Cottbus, which is situated in the Lausitz region in Brandenburg. And we do have there the structural change. So lightweight design and hydrogen is also a political topic. So lightweight, we always say lightweight design is a key technology for the structural change. So we are well organized here in this association. A lot of big projects are covered under this roof project, Lausitz Science Park. For example, CESCO. CESCO is responsible for hybrid aviation and hybrid electrics. Yeah. We do also have here initiatives like Carbon Lab Factory. I will tell you some facts later, and Sena Lab. So, and these two big projects are something a little bit related to the present slides from Raimund Grothaus. This Carbon Lab Factory is responsible in future for the manufacturing, the energy fair production of carbon fibers. So it's a project between Brandenburg and Saxony. Involved is the IWU and the Technical University of Chemnitz. And from the Brandenburg side, it is Technical University of Brandenburg, as well as the Fraunhofer Institute of Applied Polymer Science. So we will develop in future more energy efficient carbon fibers, and therefore we do need alternative precursor materials. This will be a focus in this project. The white land was situated mostly in Brandenburg, and we will scale up the whole process line in Boxberg in the Saxon side of the Lausitz region to scale up the carbon fiber production. So what is also very important is the knowledge. If we want to store the hydrogen, we do have to know the knowledge about the polymers. So one of our most important facts at my institute is the topic of the toughening. So we are able to care about the toughening of the polymers. We do this, for example, with thermosets, by rubbers or thermoplastic elements. So, and what we can adjust is the properties of the polymers are either for deep cold applications, for example, cryogenic storage or high pressure storage. So, and what we have also developed in the past is a possibility to identify the quality of the toughening of the polymer. So, and we call this OCT, optical crack tracing. So we are able to analyze pre-damaged polymer regarding the crack tracing, and directly to this we can also directly say some facts or identify the situation of the polymer regarding the toughening aspect. So these are some facts for the materials, and we do also have initiatives in Brandenburg that care about the energy production. I saw nearly similar slides from our colleagues from Slovenia. We also care in Brandenburg about the decentralized power to X production, energy production, and we call it hydrogen power plant for the garden. So what does it mean? So we do produce the energy by wind power, renewable energies, and also photovoltaic systems. And in this process chain here, we care especially about the energy production, and therefore we use small wind turbines. So we developed in the past a very good working plant for this with a rotor diameter of 3 meters. So that is able to install in your garden. And we also care in this project about the development and manufacturing of the pressure vessels to store the produced hydrogen. So this topic is centralized or strongly connected with the so-called Fraunhofer project group. It's called Fraunhofer Sena Lab, Sustainable Lightweight Technologies at the Division of Polymeric Materials and Composites, and this research group is also located in Cottbus. And in this project, we care about the manufacturing routes regarding tools. And a central point here is also the design and manufacturing of pressure vessels. And this is one aspect. We work here with automated fiber placement and filament winding. And in this project, we also develop structural health monitoring systems. And we do also care about the optimization of the multi-layer layup, the build-up. And as I mentioned, we do also the testings in this project. Permeation is also an interesting field. And regarding the bursting pressure, we work here close together with the BAM. Some aspects to our semi-finished products, we are able to produce our own prepreg systems. We have two plants, and under these industrial conditions, we are able to process our own prepregs with different impregnation scenario. The plant has a modular build-up, and it works pretty good. So we can deal with thermoplastics as well as thermosets, which is sure the focus of our institute. So, and what we can realize here is prepreg production with a maximum working width of 800 millimeters. So, and the big advantage are the different impregnation scenarios. That means solvent, water, powder, and solvent. So we are also able to process our semi-finished products, for example, the taupregs. And this is what we are doing, for example, with our filament winding machine. So what you can see here is a wet winding process. Was the first vessel what we produced at our institute, and it was exhibited at the JEC exhibition 1 month ago in Paris. So it's pretty new. And what you can see here is the production of a Type 4 vessel. We do also have the first projects that deal with Type 5 vessel, pressure vessel design. That means without the use of a liner system. Yeah, so here is the GoPro, some impressive views from the production. And this vessel was, as I mentioned, exhibited in Paris. So we have also a closed process chain regarding the automated fiber placement process. We do not have so much time. I only want to say some facts here. So we do have a slitting and rewinding unit. That means if we have produced a prepreg at our plant, we are able to slit and rewind this and to process this with our AFP unit. So this is an AFP unit from Microsem from Macedonia, works pretty good. And what you can see here is the cube where it works. And we can do here also work with a rotational spindle to do vessel designs. And we have also the possibility of the hardening, which we can realize with autoclaves. So it's also possible to do the pre-processing with multiple software systems. We can do the process simulation, and we can also evaluate the manufacturing process. Yeah, and this what you can see here is a manufacturing of a Type 2 vessel. And as I mentioned, we do have also the capabilities for the simulation and the design. And what does it mean? We are able to work or to realize the process simulation. This is what I showed you one slide before. And we can also couple this with the structural simulation. So, and there, I think this is known. We can work analytical and numeric with different theories and software codes. So, and this is very important. We call it end-to-end process and structural optimization. So one big aspect is the printed electronics. And we use this technology to functionalize composite parts, for example, to increase their complexity and the functional integrative aspects. And what you can see here is the video where we can see how it works. So what the guys are doing here is the application of a heating system. So we do work here with two different injects technologies. And what we produce here is a heating system based on a carbon fiber inject and also silver-based ink. So, and I will accelerate the video. So, and what you can see here is the printing job. Now the ink becomes hardened by infrared system. And now the carbon fiber, carbon-based ink is applied. And now it becomes contacted with power and it works pretty good. So this is only one application field. This is very easy to explain. We use this for heating systems, for example, the edge of wings for defreezing, but we can also use this approach for sensors. So, and what we are doing is also the development of sensors similar to strain gauges, but the advantage is we can apply this layer by layer, and the contaction job is very easy because of the printing technology. So at the end of the product, we care also about the recycling. Recycling is a very important field at our research group in Cottbus and in Wildau. And this is only one aspect what we do. We care about the CFRP to recover the carbon fibers. Not only, we do have also a lot of projects that deal with the complete recovery of the resources. So that means the fibers as well as the polymers. So we have also a lot of projects that deal with the recovery of the polymer bases to formulate new polymer systems based on the recovered raw materials. So I'm sorry for the problems with my slides. And I thank you for your attention, and I hope we can have a good discussion in the afternoon now. And I think it's a very good opportunity for networking and to have an exchange about hydrogen activities in Poland, which is not far away from my hometown. I only have to travel over the Nice River. And so I'm very interested in the discussion after this presentation. So thank you.
Thank you very much for being with us, and we are moving to the final presentation of today that will take place here in this very studio. Daniel Hade, Test and Validation Lead at Hydrogen Tech R&D, will present the innovative double-sided fuel cell technology SOFC solution of the future. Please kindly join me on the stage.
Hello, good afternoon. Here to talk a bit about SOFC technology, which is part of hydrogen technologies. I'm representing company Hydrogen Tech, which is located in Krakow. And also I would like to present a bit profile of our company. So, just trying to, okay, I think. All right, so first of all, Hydrogen Tech has been founded in 2018. We're a startup, we're a local company from Krakow, and the company is focused on the development of fuel cell technology based on SOFC, which is acronym for solid oxide fuel cell. And what is unique about our company is like we're owing a number of patents for double-sided oxide fuel cell solution, which have been awarded with numerous awards. And this really makes our design quite special. On the slides, you could see like one of our initial design from few years ago. And right now, I would like to make a short introduction to a solid oxide fuel cell technology. As I mentioned before, it is one of the hydrogen type technologies. What is interesting about it, it's like it works in a quite high temperature level, between 600 up to 1000 degrees Celsius. And big advantage of solid oxide fuel cell technology, it has quite high efficiency. It is easy to scale. It has very broad fuel flexibility, so it can be operated with hydrogen, but also hydrocarbons such as natural gas. It is silent and vibration-free operation. It has marginal NOx, SOx emissions and reduced CO2 emissions for natural gas. In case we would be using green hydrogen, then it's totally emission-free. And of course, as usual, there are not only advantages of the technologies, but also challenges. And here they are pointed out the major challenges that I would say that world of solid oxide fuel cell is dealing with, which is high temperature of operation, causes corrosion of the materials. It causes sealing issues due to material incompatibility. Due to that, there is also typically quite long startup time, which in typical solutions, it's somewhere between 8 and 12 hours. Stack lifetime is also quite a big issue there, and the manufacturing costs. So, and on this left side, you could see some of our design for this technology. And here I would like to point out what are the solution of our startup for the mentioned challenges. So first of all, because we're using quite unique double-side solid oxide fuel cell design, we're able to overcome and drop down quite drastically manufacturing costs, and I think that's the most important feature of our technology, that majority of the technology we're able to manufacture in-house. We're not really need to use subcontractors, or we're using, or we can really involve subcontractors in a really minimum ways, which of course decreases quite much manufacturing cost. But in addition to that, we believe that with that technology, we should be able to achieve much higher lifetime. We should be able to increase the startup time or decrease the startup time. And our solution should be ready for high dynamics of the load. It should be capable to work with number of fuels. And those advantages come from the fact that our design is fully ceramic, and we don't use a lot of materials, and the materials are really compatible with each other. So that is, I think, a major advantage, and that is the reason why we're thinking that this solution should overcome that many challenges of the market. And in addition to that, we also believe that we should be able to optimize fuel cell design for manufacturing. We should reduce production costs by simplifying production process and lean approach. So here I would like to present why the solution is different from technical point of view. So on the left side, we could see like traditional design. And as you could see, Here the hydrogen is delivered to the one side of the fuel cell, and oxygen is delivered to a cathode side on the other side of the fuel cell. And what is very typical for traditional design is like it uses this interconnect material. In our solution, what's different is like we're using double-sided solution. So the hydrogen is delivered through a channels directly to an anode, and on both sides of this layer we have cathode layer. And what is also very important here, we're not using this cathode interconnect that typically is made of stainless steel, and that also reduces cost for this for such a solution. So where is market for that? So due to high temperature operation, typically the market is for stationary applications where a bit longer startup time is not that critical. However, there are also exceptions from that rule. So there are also such technologies typically used for mobile power units for military applications, APU, which is used for trucks or airplanes. And as you could see, that really range of power of the application is quite broad, and it can range from really solution below 1 kV, 1 kilowatt, up to really, really large scale industrial solution, which are 10 megawatts. And finally, this is our development roadmap. Currently, we're on the stage of developing 1 kV stack and system. Those two activities are really currently being done simultaneously. And in future, we're planning to scale up the technology up to 5 kV, which I believe is near future. And we're also open for further development. We're looking very much into electrolysis market. However, this requires higher powers. And I believe it will be the next step. However, right now we're focused here, and we believe that should be manageable in a couple of years. Thank you very much.
Thank you very much for this presentation. Ladies and gentlemen, we've came to the final of our presentation. Thank you very much.
Thank you.
However, as some of the presentations were broader than expected, we've run out of time for the question and answer part. So we do have at least one question that I would like to ask now, to use at least a couple of minutes. And this question will be directed to Anna Maria Bocznik-Bracic. So if I may have the microphone handed to our guest. It was unexpected to discover that Slovenia has developed so many projects related to the development of green hydrogen technologies. It is quite impressive, to be honest. You seem to be convinced that these solutions can be introduced on a commercial scale in the future. Do you think it is a very unique combination of political support and countries' natural resources and potential that is required to achieve the same success like Slovenia? Is it possible to take this road in countries where one of these elements is missing? I am asking also from the point of view of ambitious European plans to transform our energy sector.
Okay, thank you for the question. It's difficult. I don't know where to start. So definitely we're still, so there must be a vision. This is first thing. The other one, there must be political support, of course, and of course it's everything about money. So if we come to the position that there will be the price of green hydrogen will be competitive with classical production processes, then of course this will be a simple story. But to come to that part, there for sure is needed political support and public money dedicated to development of such stories.
Thank you very much for this answer, and I would like to address the aspect that all the questions that we've received during our conference, our debate for today, will be answered at the side of the conference. So we won't leave those questions unanswered. We will pass the questions to the respective presenters, and then we will present the answers on the website. So we really appreciate your cooperation and your involvement by asking those questions via chat. Thanking you for being with us here within the audience and also online via the stream. I would like also to thank all the presenters for their effort and for all those unique perspectives that they presented to us. And I would like to invite you to 3 events. The first one will take place in Krakow. This will be the 28th, 29th of September. This will be another meeting dedicated to hydrogen, the International Trade Fair for Composite Materials, Technologies and Products, Composite Exp. This is one of the most important events of the composites industry in Poland and Central and Eastern Europe. On June the 9th, there will be also a conference dedicated to the hydrogen, Go Green Hydrogen Solutions from Poland and Belgium. The detailed information about the event can be found on the following websites: innowacyjna.małopolska.pl and gov.pl. And the third is the closest to our hearts because of the because we are the part of this festival. This is Małopolska Festival of Innovation, taking place on June 20 till 26th. Please visit the website of Innowacyjna Małopolska. You will find there the program of the events of all the partners of the festival, and also the program of the conference, which motto is Innovations in Małopolska, we think horizontally. I hope I will have the pleasure to see you during this conference, and once again, thank you very much for being with us, and expect the answers to your questions on the website. Thank you very much all for joining us here live as well.